Hide the planet! Hide the planet!
We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, HackerFrogs. It's me, the Shy Hat, and we're doing HackerFrogs AfterSchool today. We're doing HackerFrogs free hacking. We're hacking all the things. So let's talk about what we're going to be doing today, and let's get into it. Red Sly Fox, hello, nice to see you here. How are you doing? But yeah, Waffler was just asking us about doing CPTS, which is the certificate from Hack the Box, in a couple of months, and they're asking for tips. So my tips for CPTS, because it mostly has to do with Windows Active Directory environments, is just to do as many Windows Active Directory boxes as you can on Hack the Box, and do a lot of documentation so that you don't come across anything you haven't seen before when you do the CPTS exam. But aside from that, just take a lot of good notes and do a lot of exercises. Just get yourself into the mood of doing a lot of hacking boxes, because that's that's a lot what the CPTS is. Okay, and Maureen Ferguson, hello, nice to see you here. What is up? What are we doing today? So we're going to be doing 4 topics. Well, we're not going to be doing our puzzle games, but instead we're going to be taking a look at some binary exploitation exercises. But that's after we do another thing, which I need to do, which is make up the schedule for next week, because it looks like it kind of slipped my mind. But we can do this together if you want to see anything for the challenge topic, or if you want to see something for the warm-up topic, or if you want to see something else on Sunday, which is kind of open. It doesn't have to be coding. It could be gaming, it could be something else. Let us know. David Ferguson, hello, nice to see you here. Yeah, thank you very much for letting me know. Maybe I'll just call you Mr. Ferguson. That'll get me out of trouble. Okay, so we're doing we're going to be making our schedule, and then we're going to be doing some binary exploitation. We're also going to be doing the OverTheWire Bandit Wargame. I'm going to walk through a bunch of the early levels, or as many as we can do in about an hour or so, and explain what's going on with this war game. So this coincides with our HackerFrogs AfterSchool topic, which is Linux OS operations. And you do a lot of Linux OS operations when you do this war game, because it's mostly Linux based. Well, it's completely Linux-based. Anyways, the third topic is we're going to be talking about Linux OS operations. So the very basics, we're going to be getting used to file management. We're also going to be playing around with the grep command, which is very, very important when you're parsing through files. Okay, where are you doing the binary exercises? Yeah, the binary exercises we're going to do in a bit are going to be at HackerProgs. Let me see if I've got that on screen. No, I don't. Where is it? Oh, here it is. Thank you very much. So Tei, thank you. Thank you very much for the... Are you doing Leviathan? No, we're not going to be doing... We're not going to be doing over-the-wire Leviathan, but we are going to be doing Bandit. Okay, but before we get started, well, let's go ahead and start the timer. So the first segment is only supposed to take about an hour or so, and I'll talk about the last topic we're doing today, and then we'll get off to the races. Okay, so the last thing we're going to be doing today for our challenge is we're going to be spending a bunch of time learning about NoSQL Injection Challenges. So there are two types of regular databases that are used by web applications, and there's SQL, which is a relational database, and there's NoSQL, which is a non-relational database. What that exactly means, well, we'll find out when we get to the topic, but they're different types of systems, and there's different types of vulnerabilities for these, but they're kind of similar to the ones that we see in normal SQL systems. We'll talk about it when we get there. We're going to be working through some of these challenges over at Portswigger and learning about those NoSQL vulnerabilities. Anyways, let's make up the schedule for next week. The schedule for next week, we've got August 23rd, August 25th, 26th, and 28th. These are our regular streaming days right now, and we need to come up with some topics. So we're going to keep our regular C coding course over here because I need to get better at C coding. Leak Code Quest, we can replace that with something else. Keep in mind that this is a short stream that we do on Sunday, and it usually goes for about 3 hours. And we're usually doing something a little bit more, well, a little bit more chill. Although I guess leak coding is sometimes not so chill. But if you got some suggestions for that, let us know. What else do we have? So let's see. For the regular streams on Wednesdays and Fridays, let's see. For our warm-up topic, I guess we can do puzzle games, Thinky Games Dailies. I'm not too sure what puzzle game we're going to be doing for the second one over here. Cairo Law, nice to see you here. What is up? Hope you're having a good time. And let's put on a little bit of music in the background while we do this. Just a sec. Okay, it's a bit loud. It's a bit soft, hold on. Okay. Yeah, so, I've got a bunch of puzzle games that I've been working through, but we don't necessarily have to do a puzzle game for this either. Maybe we'll do some reverse engineering, because I need to revisit some of the topics that we finished. So let's see. Revisiting reverse engineering. So we'll do that for the first topic on the 28th. Let's see. For our second topic, yeah, maybe we can do Over-the-Wire Bandit. OTW Bandit. And we'll take a look at the new levels, because they've updated the game with a couple of new levels. Let me check. So Over-the-Wire. And I think it was Pretzel Pete that was talking about that. How long have you been in cyber again? I've been learning about cybersecurity concepts for about... I'm going into my this is my 6th year. So already 5 years. Okay, so there is a level 33 and a level 34 now that we're not there the last time I did this. And when so let's take a look at those for our second topic on Friday next week. So 33 and 34. We can do our HackerFrogs AfterSchool topics, because we're going to be continuing with the course. And then for our challenges, I'm not exactly sure what we're going to be doing for challenges. OTW is the Occupied the Web guy. Well, I mean, in this case, it's OverTheWire, which is a different acronym. But yeah, I finished all the levels. So fun. That's not what you said earlier, but sure. Okay, so what else? I think we're gonna be doing. Oh, you know what? We need to keep up with doing the Hacker Holidays topics. So Hacker Holidays. And we're going to try to finish off the Hacker Holidays challenges. It's going to be days 11 to 14. So 11, 12, 13, 14. That's 4 challenges. I don't know if we're going to be able to finish it. But to balance everything out, we should probably do something from Hack Smarter. Can you make labs like Active Directory? Make the labs? What do you mean by make the labs? Hold on. So maybe we can take a look at Hack Smarter, because Hack Smarter is, well, we need to balance out the Try Hack Me with Hack Smarter. I wonder if they've come out with any other new labs lately. Let me take a quick look. Casino Medium Lab, Medium Web, and Linux Challenge Lab. Did we do this one already? I can't remember if we have yet or not. Sysadmins. I'm pretty sure I've. So maybe sysadmins from Hack Smarter. Maybe second from Hack Smarter, because this well, we need to refine our AWS cloud hacking abilities. Yeah, let's challenge ourselves with a little bit of AWS hacking. Okay, so this is going to be second. So Hack Smarter second, which is AWS. And I think we've got a full schedule now. Okay, so I'll just copy this. I'll make up the schedule and I'll publish it after the stream is over. But let's get going. Okay, Mr. Ferguson says, I've not been following your video for some time now. Please send me your GitHub link so I can follow you from what I've missed. Okay, so I've got a GitHub over here that you can take a look at. It should be in the chat. Alright, let's get started with our binary exploitation. It was about 10 minutes. HackerPoll. Okay, so we're going to be doing some HackerPoll pwn challenges, which are binary exploitation. We're going to see if we can do like an easy binary exploitation challenge. Easy in quotes, of course. We've done a few of these. Let's see if we can do this one over here called UID. So it's pwn x86-64 and stack, which usually implies like buffer overflow stuff. Alright everybody, if you want to join along with us, you certainly can. You are asked to use the provided binary to read the flag.txt file located on the remote server. Okay, so the first thing we need to do for this is we need to download the Docker Compose file, because we're going to be standing up the infrastructure for the challenge on our own machine using Docker. Just rename this our Docker tab, and I'll give each one of these fancy color, just so I can tell these tabs apart from each other. So if you have any questions about cybersecurity or tech topics in general, anything that we're talking about, feel free. I'm happy to talk about this while I work through these challenges. what else do we need? We'll probably need like some sort of research tab. Okay, so we'll make a directory for this. Thank you very much, YX Godzilla. Thank you. Thank you very much. Make directory, we'll call this HackerPol, and then we'll enter it, and then we'll download the Docker Compose file. Amen, hello, nice to see you here. Hope you're having a good Friday. TGIF, everybody. Okay, so we downloaded that, then we need to launch the Docker container with Docker Compose up. And let's make another, we'll call this binary exploitation. Okay, and then we'll download the binary we need to analyze in here. It's called UID. Okay, so we'll just copy the link. And if anybody wants to play around with it yourself, here's the link. You shouldn't have to be logged in to get this file. Or maybe you do. No, you don't. Okay, great. Alright, first thing we'll do is we'll make the file executable. And then we'll just run a quick strings on the file to see if there's anything really weird that stands out. So we see here what kind of functions the binary is using. It uses stuff like scanf, printf, and system get EUID. Okay, so we should probably look out for that. So we need to do a little bit of reverse engineering on this as well. So we'll try running it. Username. Username, I mean, this is a binary exploitation challenge, so it's probably some sort of buffer overflow. Segmentation fault. Catflop.txt, no such file or directory. Flop.txt, that seems weird. Okay, so let's see. Godzilla says, I've just started learning cybersecurity, but I feel lost, like I know I've got to learn the fundamentals, and I'm trying. But there are times like I feel like everything I've learned is a waste of time. Everything you've learned is a waste of time. Well, I mean, okay, I've got to get into cyber thread. Someone forgot date to flop.txt. I'm not sure about that. But yeah, Godzilla, take a look at the link over there. I swear it's not a virus. It doesn't lead to any malware or anything like that. It does lead to a Reddit thread where we talk about how to get into cybersecurity. Basically, the first thing you need to do is you need to figure out what your preferred type or specialization in cybersecurity is, because most people in cybersecurity are highly specialized. So people who do pen testing do different training from people who do digital forensics, who do different training from people who do malware analysis. So the first thing you might want to do is figure out what your niche is, and then come up with some training and like a learning path that fits that particular type of specialization. So it says, I swear it does lead to a virus, a mind virus. Well, I don't know what to say about that. Alright, so it looks like we crashed the program, and it tried to read a file called flop.txt. Let's go ahead and make that. Flop.txt. And we got the flop. Okay, so we'll try running that program again. We'll try crashing it. Yeah, Professor Messer's a good starting point. So we got the flop. So I'm guessing that this binary can read flop.txt or flag.txt. And you know what? The only way to find out is to do some debugging on it. So we'll run the debugger tool. So we're Dare2, we'll analyze the binary, and then we'll take a look at the functions. Actually, we'll take a look at the main function first. Okay, so it looks like it either reads flop.txt or flag.txt depending on some factor here. There is a comparison that is done over here against something in var4h. No, it compares 0 against whatever is in the var4h variable. And I'm guessing the var4h variable is our user input. That's what I'm guessing. So if it's not equal, it jumps to this over here, catflop.txt. But if it is equal, then it jumps to catflag.txt. Okay, let's go ahead and make that file as well. So we'll echo out to flag.txt. We got the flag. Okay, Mr. Ferguson says, I don't know the one to pick, red team or blue team, which one is best? I mean, try some of both and see which one fits your personality better. So whether you're doing defensive cybersecurity or offensive cybersecurity, it has to fit what you prefer to do. So I would say do some exercises from both, and then think to yourself what would you like to be doing with the majority of your time. Is it defensive cybersecurity or offensive cybersecurity? Okay, so so it compares whatever's in var4h with 0. I guess we can set a breakpoint over here, and we can find out whether or not this is actually our user input. So we'll set a breakpoint for that, then we'll run the program. So we'll put in a big username. Okay, then we hit the breakpoint. And at the breakpoint, we want to find out what is in this var4h variable. So all variable list. So var4h is at RBP, so the base pointer minus 4 hex. We can take a look at that. Huh, so this is just a single letter A. I guess it only takes in the first thing. Okay, Mr. Ferguson says, my laptop is bad for now. Is it okay to learn with an Android phone? Learn with an Android phone. I mean, no matter how bad your laptop is, it should be able to run some sort of Linux, but there's also a lot of like web accessible Linux machines you could use as well. I mean, they're going to be sufficient for all of your training, but for the beginning of your training, doing stuff like, hold on. So hardware considerations and starting cyber. So you don't need a dedicated cybersecurity PC or laptop, especially at the beginning of your learning. So there's a lot of web accessible machines you can do your study on. So some examples of this include stuff like the TryHackMe attack box, stuff like the Pico CTF / Scilab web, what was it, WebShell? And there's also, if you're just learning basic Linux, you could also try using JS Linux from Bellard Labs. And I think I've got most of the stuff in my like Linux education resources. So if you're trying to learn Linux, here's a list of resources over here. So we've got a bunch of courses, and then there is some CTF challenges you can try. And Explain Shell is very nice for explaining different commands in Linux as well. And Bellard.js Linux is a good, like, free web accessible machine that you can play around with. Okay, but yeah, I understand that hardware limitations can be rough. I think you should continue using your laptop. You can continue using your laptop. You might want to consider putting like trying to install a light version of Linux. I think like Alpine Linux is very lightweight, but don't take my word for it. I'm not really a Linux distribution expert or anything. Okay, so it looks like we've got A in there, and they're comparing with 0, right? We got the flop. Okay, we'll just reset. Okay, so it still does we got the flop, even though we put in what they want us to compare it with. Okay, let's take a look at the main function again. So they do the compare word against 0. And then they shunted us off over to catflop.txt. Okay, let's try that one more time. So we'll run the program, we'll put in 0 as the username, we hit the breakpoint, and then we'll take a look at the contents of the variable. Huh. That's weird. I think something weird happens to... Okay, so the other thing we need to figure out is how exactly they save our user input. So let's take a look at the main function again. Okay, so get EUID, so it changes our effective user. Mr. Ferguson says, the screen is blank, the battery is bad, and some of the keys are not working. Okay, that actually does sound kind of bad. So I would say, yeah, I mean, any old laptop will do as long as it's working. I guess a non-working one doesn't really help you too much. Cypher asks, how long does it take to understand this? Done plenty of challenges, but not getting beyond very basic. Beyond the understand this, you mean like binary exploitation? It takes a while to do binary exploitation stuff because there's a lot of underlying stuff you have to understand to do these challenges. So the prerequisites for this particular category of cybersecurity is kind of high. Okay, so Mr. Ferguson, yeah, the hardware is bad. I don't know if I should use the Android phone for now. I mean, yeah, that's tough. If you don't have access to like a PC or a laptop, like something that can at least run a web browser without struggling, that can be a problem. Benjamin Sesko says, as a beginner, what should I do? Any first suggestions? Yeah, take a look at this Reddit thread over here. Sorry. Get into cyber. There we go. Just take a look over there. There's a lot of resources that that can help people get a feel for what they should be doing first. I can't get beyond the basics, or is it the way I'm learning it? I'd say take a look at the Reddit thread that I linked through tinyurl, and it should help you out. Okay, so get UID, okay, and then it does the printf, and then it does scanf to take in the username. Scanf to take in the username, and then it does comparison immediately with 0. Maybe what we need to do is we need to overflow the buffer so that 0 gets put into the var4h. Because I think our user input is put into var30h. Alright, let's confirm that. Run the program, put in HackerFrogs as the username, we hit the breakpoint, and we've noticed there were 2 variables. There's one at var4h and var30h. Let's take a look over here. Okay, so our HackerFrogs variable is over here. So Cypher says I can't figure out the assembly like I can other programming languages. Assembly is it's a pretty special beast. It doesn't work like other it doesn't work exactly like other programming languages. You don't necessarily have to know a lot of assembly language to do even like binary exploitation challenges. You just need to know enough to get a gist of what's going on. Where I would start is with like a course like ASM Tutor. So asmtutor.com, do the first maybe 10 challenges there. It'll really help you out. Another thing you could do is you could take a look at assembly language over at Exorcism, exorcism.org. They've got a bunch of assembly challenges that you can do over there. Okay, so let's try overflowing the buffer and getting into the other variable with a bunch of zeros. Oops. Just a bunch of zeros. We're not quite there yet. But we do see that our zeros got into the 30H. Over here. Maybe we just need to send more of these. How many more of these do we need to send? Maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe 10 more. But how many did we send initially? Hold on. Let me count these. So that's 35, maybe we'll do a 45. So we'll just use some Python, we'll print out 0 times 44, 45? Whoops. There you go. Okay, and then we'll put this in. Hey, Ralph Streamer, nice to see you here. Yeah, there's also people watching on YouTube, but yeah, you know, if you enjoyed the stream, tell your tech-minded friends about it. If you've got other people who are looking to get into cybersecurity, I'm happy to answer questions. Okay, where was it? Over here? Okay, now let's take a look at what's in our registers, our memory registers here. Not the registers, just the memory locations. Okay, so we got it in. Okay, and so we should be able to get the flag now. We still got the flop, we didn't get the flag. But why? We've got the correct value in there. So we used buffer overflow to overflow into the other variable, and there was a 0 in there. So compare whatever's in var4h. I wonder what's initially in there. So move whatever's in EAX into var4h up here. Okay, let's send one more than what we have. Then let's inspect the two. So we got 0, 0, we got 30 and 30. And then we've got a bunch of zeros like we put in there. Raffle Streamer says, what's your opinion for using tools like local LLM for hacks and for enumeration stuff? I actually don't know very much about running LLMs locally, and I also don't know very much about running LLM agents, so those are two areas where I don't have very much knowledge. Like local LLM? When you say local LLM, is that like a specific thing, or are you just talking about local LLMs? I'm not too sure. Okay, so we still get the flop. We do the comparison var4h with 0. If it's not equal to 0, we jump to here, where we cat flop.txt. So the other thing about this challenge is that the challenge is called UID, and UID refers to like user permissions. That probably has something to do with this challenge. Oh, you know what? Let me check to see if there are any additional variables in the program. Not variables, functions. Okay, so there's a system function printf, get e, UID, fflush, scanf, finalize. But yeah, there is something about the get UID that we need to pay attention to, probably, to finish this challenge. Because it calls get EUID at the beginning of the program here. Okay, Ralph Streamer says, like local KI with tools like LM Studio or Olama to use free key models that help a lot of stuff. But okay, you haven't used it. That was a question if you use them or not. Yeah, I don't use stuff like that. Oh, key equals AI. Okay, I'm not familiar with it. Sorry to say. So we record our... So if it sees 0 in there, it should not jump and then load catflag.txt and then run it with system. And then jump to the end of the program. So either way, it's calling system to run cat something something. So catflop.txt or catflag.txt. Let's try exactly to get into var4h again. Okay. Then we'll take a look at the... So we got a 0 in here. Maybe they're looking for a 0 in this part of the register here? Maybe they're looking for this byte. But that doesn't make sense because the beginning of the register for our string is this one right here. Let me just double check. Which distro do you use? I'm using Kali Linux. Yeah, so this is the beginning of the variable here, this byte at the far left. Oh, key is the German word for AI. Oh, you're German, Raffle Streamer. Nice to hear. Nice to hear. There's a person who used to stop in pretty regularly to this stream, who was a German tech enthusiast. His name was Diefus Modernes Leben, and he streams a lot of like IRL stuff on Twitch right now, these days. Okay, so we got our 0 in here. So it's being compared against 0. Compare dword var4h with 0. But it's not working. I'm not too sure why. I wonder if we can actually get into the other registers if we overflow enough. The German IT community is really big. You have to visit the CCC in the end of October, December in Hamburg. It's the biggest community event in Europe every year, and it makes a lot of fun. Oh yeah, I've heard of Chaos Computer Club. the conference over there. It does seem like it's a really good time. Okay, so it looks like we haven't managed to get into any of these other registers, but we should probably check. So like PX at RSP. You know what? We might be able to redirect to program execution, right? So if we, because the stack pointer is where the program returns to. So if we run this, it should crash. Hold on. Tattletale, hello, nice to see you here. I didn't know you spoke German. So that crashed the program. We got the flop, and then it crashes. So maybe what we need to do is we need to run... Maybe we need to run the system command. Because we know that the system function is in the program. So the system function is in the program. If we can call it, but we also need to put whatever we want to run instead of RDI. I wonder if we can control RDI as well. Okay, so we'll just put in all of our zeros, and then we'll take a look at the contents of RDI. Something tells me that it's not really going to work, though. Yeah, we got the flop. RDI should contain the we got the flop string. So PX at RDI. No, it doesn't contain anything anymore. Mr. Ferguson says, what about DEF CON? Is that going on? I wish to go someday. Yeah, DEF CON happened a couple of weeks ago. It was like early August. So I think it's been at least like 2 weeks since DEF CON happened. But yeah, everybody usually has a pretty fun time over at DEF CON. I haven't been myself. Maybe one of these years. Maybe not anytime soon. Okay, so the first thing we need to figure out is why doesn't the execution work for me? PDF at main. Alright, so let's talk to our favorite AI, who is Gemini, and Gemini doesn't have any qualms about doing hacking stuff, unlike some other LLMs. And let me pull it up. Okay, Red Sly Fox says I want to go to DEF CON as well. That's awesome. Maybe one of these days we'll do a HackerFrogs meetup at DEF CON. That'd be pretty fun. Okay, so we are doing a BinX challenge, and we managed to overflow the buffer and replace the variable at, what was it? var4h with 0, but it didn't trigger the reading of the flag. Can you identify why? Boom, here's the disassembly. Ibrahim, nice to see you here. What are we doing right now? We're just doing some binary exploitation challenges right now for the next 15 minutes, and then we're going to move into another topic. Okay, so the root cause, it stops at whitespace. So the format string reads characters until it hits the first whitespace character. So the space tab new line, if your payload contains any whitespace, scanf will truncate it, meaning your overflow might be cut short. I mean, that didn't happen. Look closely at the comparison instruction. Compare dword var for h 0 followed by jump not equal. So var for h is a 32-bit integer, not a single byte. If you successfully overwrote it, you need to ensure you wrote a full 4 bytes of zeros in proper little endian format rather than just a single null byte. Otherwise, well, I mean, wait, are they looking for a null byte or are they looking for a 0 in ASCII? I guess we should ask this. So is the program looking for ASCII character 0, or is it looking for a null byte, for a hexadecimal null byte, or hexadecimal 0? So that would be slash, what was it? 0x00. What GPU do I have? I mean, I think I've got some specs over here you can take a look at. Long live Scotland. Gnostic, hello, nice to see you here. I haven't been to Scotland anymore, but there's a lot of Scottish people in my country, Canada, and a lot of the historical figures in Canadian history were Scottish. Hello, nice to see you here. Hope you're having a good day. Looks cool. Not gonna lie, I have zero idea about anything you're doing. No worries. Okay, the program is looking for hex 0, not the ASCII character 0. Oh, okay. Sorry, for some reason I thought that was looking for the ASCII character 0. So it's looking for hex 0. I mean, that's fine. We can probably do that through Python or Perl. Yeah, I'm Canadian. Thanks for asking. Okay, let's go back here. So we'll try feeding this into the program. We'll run some Perl and feed it into the UID program. So in this case, we're going to be printing hex 00, which is the null byte, and we're going to print it, I don't know, like 45 times. And then we're going to redirect it into the UID program. Not Perl again. Well, I mean, Perl has its uses. Sometimes it's just easier to use Perl than it is to use Python. We still got the flop, though. Well, how about we try... ...48 characters or like 50 characters. So if we just print this out, we shouldn't see anything because this is a non-printable character. But if we were to print out something like A, then we would say, oh, we didn't print out enough. Okay. Sorry. I wrote my Perl command incorrectly. You know the Netflix serials Letterkenny? I love them. I don't think I've seen Letterkenny before. What are you trying to accomplish looking for right now in this challenge? So 5-5, hello, nice to see you here. So we're just trying to figure out how to do a buffer overflow attack. So we need to overflow a memory buffer with a bunch of characters. So look, okay, so I think we've got this working now. So this is some empty stuff. We'll redirect it into UID. We got the flag. Awesome, awesome. Okay, so the problem was that I was mistaking the ASCII character 0, which is, well, I guess we can talk about it very briefly. What went wrong? We thought the program was comparing our user input with the ASCII 0 character, which is like hex 33, hexadecimal 30. The program was actually looking for the hex byte 00, which is 0x00. I hate binary hacks and ASCII stuff. Are we doing Bandit next? Yeah, we're going to be doing Bandit next, but we're not going to be doing the new levels. We're going to be working through the from the beginning of the game. Okay, so yeah, so all we need to do is we need to feed this to the server version of the program. So in the server version of the program is currently on localhost 4000. Courage tout peut le faire. Tout peut le faire? I'm not too sure what that means. Courage means courage, I'm guessing. Thank you very much for subscribing on YouTube. Craig Murphy, thank you. Much appreciated. Okay. Tout peut le faire. Tout peut le faire? My French is not good. Let me translate this. France. Okay, so from French, tu peux le faire means you can do it. Okay, so I guess thanks. Thanks, buddy. Alright, so we'll just redirect this into netcat localhost 4000. And we need to add a new line character to this after all of our null bytes. So the new line character is hex 0A, and then we get the flag. Are we doing Bandit next? Yeah, we're doing Bandit next. Pretzel Pete, but we're starting from the beginning. Okay, so we got the flag, we can submit this, and then we can do our write-up. It's a pretty, well, it shouldn't have taken that long, but we got there in the end. I say that a lot, I guess. Alright, paste in the flag. We're done. Challenge flag is correct. Nice play. All right, so let's do our little write-up because we need to document things. If you didn't document it, it didn't happen. That's what they say in cybersecurity. This is for HackerPoll in the Pwn category of challenges, and it's called UID. Super excited to see it try. Yeah, Bandit will be a great refresher. Plan on doing a rerun from the beginning soon anyways. So we're gonna try to explain the stuff. We're gonna try to keep going as fast as we can while also explaining what's going on. Okay, so this challenge is called UID. We'll record a couple of different things like the URL where you can find the challenge, the concept. We need to understand the challenge and the method of solving the challenge. Okay, now I recommend for anybody who's studying cybersecurity to document all the challenges that they do, especially for the commands that they use, because it's very easy to forget specific little bits of code that help you solve the challenges and commands you use with the tools. Okay, so the concept here is stack buffer overflow. Although, is it really stack buffer overflow in this case? I guess it is. Okay, so stack buffer overflow and variable overwrite. This is an example of an overwrite to win challenge. Okay, was the challenge who got over with no premium account? No premium account. Smart, I use Notion. Yeah, use whatever. Okay, well, I mean, I do use AI for my thumbnails because I can't create unique thumbnails for all my stuff. I mean, if you don't want to watch the stream because I use AI art for the thumbnails, that's fine. Okay, so let's see. Method to solve. The first thing we do is open up the binary in... Oh, is the challenge is it for non-premium users? Yeah, I mean, use AI thumbnails if you need to. I guess there's some communities that are really against people who use generative AI, especially image generation, but oh well. Okay, so the challenge, is it still online for non-premium users? Yeah, it is online for non-premium users. You don't need... The stuff I cover is mostly free stuff. So if you want to take a look at this challenge, it's over here. Okay, so let's finish this walkthrough, and then we'll get on to the next thing. Open the binary in a debugger, or a debugger. So we run like Radare2 in debug mode on UID. And then we analyze the binary, so with quadruple A. Then we run all PDF at main. So this gets us the disassembly for the main function. So we see, I guess we can also just give the entire disassembly. This is the disassembly for the program. Okay, that was not the question. I think you know Hack the Box, right? And the non-premium challenges are online for like 4 weeks or something like that. And after that it's premium, but in the first 4 weeks it's okay to load online. Oh no, I can't cover any of the free stuff from Hack the Box. So Hack the Box specifically says that if it's not a retired challenge, you can't do YouTube videos on it, and you can't do like write-ups on it. So I can't cover any of the non-premium stuff from Hack the Box specifically, unless it's like evergreen. And there's very few things that are evergreen and retired on Hack the Box. You can find the old challenges everywhere on Git. I mean, the old challenges are different from the new challenges. The old challenges are okay to document, and they're okay to make videos about. Yeah. I mean, IPSec covers... he doesn't cover new challenges. He doesn't cover the free challenges. The free challenges are not evergreen. They're not... they're limited time. Okay, so let's get the disassembly. So essentially, the program takes in user input, then compares the user input with, whoops, with the 0x00 byte. So this is a non-printable character. So we need to use some program like Python or Perl to input that byte. Okay. Doesn't IppSec get paid by HackTheBox? I mean, I'm not sure. I'm pretty sure that IppSec is like affiliated with HackTheBox in some way, but I'm not sure if he's getting paid to make his videos. Okay, so he uploads the free challenge that is so old that there only arrives with a premium account. You don't get the points anymore. HackTheBox. How often do you stream? I stream... Well, my schedule's on Reddit. Over here, and I stream 4 times a week. 2 of those are casual late night streams, and 2 of them are less casual streams. Okay, sorry. What was I? I was doing my write-up. Let's see. I think, so SysOS says, I believe IppSec has made specific recordings for HackTheBox. He might have other deals as well. He has some live streams on the Discord there, like yesterday. Okay, well, I mean, listen, it's very hard for me to do HackTheBox content. Why no HackTheBox on your channel? I can only, not legally, but thank you very much, Kobe for Accuracy, for following on Twitch. I can only document retired challenges. There are retired challenges that are free, but they're only free for a limited time. They're only free for a limited time, and I only want to cover evergreen content, which is stuff that you can find at any time and is not limited time. Okay, Tattlesale says, some say that HackTheBox is a waste of time. I wouldn't call HackTheBox a waste of time. But some videos he has from Try Hack Me as well. Oh, well, I mean, IppSec wouldn't limit himself to just HackTheBox. I mean, he primarily does HackTheBox, but he does, unless he's got some sort of exclusivity contract with HackTheBox to not cover stuff from Try Hack Me. I don't know about that. Anyways, but that's why I don't cover a lot of HackTheBox stuff on my channel. Okay, we need to use some other program like Python or Perl to input that byte, and we also need to use buffer overflow to overwrite the actual value, or the actual variable being compared. So for example, this is assembly. Where is it? Compare dword var4h 0. Our user input does not get put into var4h. It gets put into var30h. So we need to overflow the memory buffer. To put a single 0x00 byte into the var4h variable and trigger the cat flag.txt system function. Okay, yes, in the post he has try hack me too. I looked since like 5 years or something. You hacking stuff since like 8. You do hacking stuff like 8 years or something like that, but just for fun when I have time. Oh, okay. You do defensive cybersecurity. That's pretty awesome. Okay. Alright, so the required overflow bytes, the required overflow bytes for this binary is 45. So this Perl command will send the required number. Okay, we got our good old Perl. I know Mako loves Perl. Where was that? Done. Okay, also Tyler Ramsby. Yeah, Tyler Ramsby, who does Hack Smarter, also has a cybersecurity platform, and he doesn't have any restriction. Or at least I don't think he has any restrictions on the type of content that is allowed to be put online. Okay, let's go ahead and put another hour on, and we're going to do another topic. So our next topic is going to be, oh, this is a bit loud. Okay, this is going to be on the Bandit CTF. So this is from OverTheWire.org. Who is Ryan Montgomery? Mr. Ferguson, hello, nice to see you here. Ryan Montgomery is, he's a I don't know if he's a content creator, but he's a figure in the cybersecurity community. And he used to do a lot of stuff with Try Hack Me. I think he's got his own company now. You also see him on like YouTube videos talking about hacking content. But aside from that, I don't know too much about him. Okay, so Over the Wire is a website which hosts a lot of cybersecurity war games. So war games are basically little series of challenges that require us to use our cybersecurity skills to solve and to get to the next level. But it's not always strictly cybersecurity. Sometimes it's about Unix and Linux basics, which is what Bandit is all about, but there's also some security sprinkled in there as well. So we're going to be doing the Bandit game, and we're going to be talking about how to solve these challenges. Okay, so let's talk about this. I'll just read the description here. The Bandit Wargame is aimed at absolute beginners. It teaches the basics needed to play other war games. Let's see. The game, like most other games, is organized in levels. You start at level 0 and try to beat or finish it. Finishing a level results in information on how to start the next level. So what we need to do is we need to start by connecting to the server, to the game server at level 0 over SSH, and then start solving these challenges. So for example, we can click on level 0, and it says the goal of this level is to log into the game using SSH. The host to which you need to connect is bandit.labs@overthewire.org, port 2220. The username is bandit0 and the password is bandit0. Okay, so let's copy this. I mean, I don't think I'll need all that much help with bandit level 0. Maybe when we get to bandit level 33 and 34, I might need some help then. Okay, so we're given this information here. So log in to the game using SSH, and we're given a host, which is bandit.labs@overthewire.org on port 2220. So we just need to fashion this into an SSH command. So this is port 2220, and the username is bandit0. So we'll put this in front. And finally, the password is bandit0. We're just going to have to remember that. Just put an SSH in front of this. So this is the command we use from the terminal to log into bandit level 0. Okay, Red's Life Fox says, are you going to play Star Wars Zero Company when it comes out? I know you sometimes play games before hacking stuff. I mean, most of the time when we play games on the channel, we're usually playing games that have something to do with either puzzle solving or technology in some way. Star Wars Zero Company is kind of like outside that, but maybe when I do like a stream that is just games and not having to do with like tech stuff. I haven't heard very much about Star Wars Zero Company. But anyways, let's go ahead and log in. So we'll just rename our binary exploitation tab. Bandit CTF game. Make it red, because red is cool, or red is hot. Okay, so just run the command, and this will connect you to the Bandit CTF server. Okay, and we're going to have to put in a password. It might ask you if you want to continue connecting. You have to type in the word yes and then hit enter. But we need to put in the password. So the password for Bandit level 0 is bandit0. You can copy this, and then you can paste it, and then hit enter. When you put in a password using Linux, you will not see anything appear on the screen. That is normal for Linux. And then after you run the command, you're logged in. So you'll know you're logged in because you'll see this prompt, bandit0 at bandit. So the prompt in a Linux terminal tells you some information. So it tells you your current user and the name of the server. So the name of the server is Bandit, and we're currently at our home directory. So the home directory is indicated by the tilde. Exut. That's I'm sure there's some language that spells exit with a U. Alright. So typically in a Linux environment, you'd use ls to take a look at what's inside the directory. So ls to list out the directory contents, pwd to show you which directory you're in. So we're in this directory, /home/bandit0. So if something begins with a slash, that is a directory in Linux. Actually, no. If something ends with a slash, that is a directory in Linux. Well, I mean, it's not for sure. I guess begins with a slash. Most of the time, if it begins with a slash, it's a directory. Anyways, okay, so what do we see? So there's a README file in here. cat readme grep password. Yeah, I guess we could. But yeah, if we want to read a file in Linux, we just need to use the cat command. So cat stands for concatenate. It means put something onto the end of something else. So cat readme to read the file. So it says the password you're looking for is, oh, okay, that's a pretty long password. The passwords used to be shorter. But what you want to do while you're playing this game is you want to record these passwords somewhere, because you might want to come back to these levels later, right? So copy the password, and in another terminal, we'll echo something between some quotes, and then we'll output it to bandit pass. Actually, we'll double greater than to bandit pass.txt. Okay, so we'll just put that in there. And we'll also put in bandit 1, because that's the next level. So bandit 1, colon, and then the password. This is the typical format for usernames and passwords in a bunch of different systems. Okay, try LA only. Try LA only. LA isn't a command, LS is a command. But LA is an argument to the ls command. Okay, so this is the password. And just to make it a lot faster, we can actually just switch over to the next user. So switch user, actually I don't know if they let us, but we'll try. So switch user bandit 1, password, authentication failure. Let me try that one more time. So some servers don't let you switch users on the server. You need to do it via SSH. Switch user bandit 1, paste. Okay, so we can't directly switch users, so we need to exit from the server. Try LL. LL. Oh. LL is some sort of shortcut for LSLA or LSL. I don't use these very often. It's an alias. Okay. LL is a shortcut for LSLA. Okay, let's exit, and then we will run the next level of the program, or the game rather. So I'll, just for convenience, if you're playing along, this is the command to log into the next level, and the password that you need is this one. Okay, we run the command, we paste in the password, and that lets us into the server. So for each one of these levels, we need to go back to the level description over here to let us know what we're supposed to do in the level. So this is level 1 to level 2. And our level goal in this level says the password for the next level is stored in a file called dash located in the home directory. So an interesting thing about this is, well, we're dealing with Linux file name conventions, right? So the thing we have to understand about this, actually I've got a presentation file for most of the levels of Bandit. Let me go ahead and get that. So the information is a little bit outdated, but should be still okay. OverTheWire Bandit, banditexplained.pdf, okay. Robvo, hey, what's up? What's up? Okay, Bandit 0 listing directory contents, reading file contents, pasting in passwords. So when entering in passwords for the Bandit CTF levels, we should paste in the password instead of keying it in. I mean, keying it in is not really feasible because it's just a bunch of like random letters and numbers, and you also don't get to see what you're typing in. So you need to paste it in. So right-click, select Paste Clipboard, or on the keyboard shortcut, you can use Control-Shift-V to paste in your password. Okay, if the screen becomes too cluttered in Linux, we can also use the clear command to clear the screen and go back up to the top of the screen. So it's a pretty handy little, where am I? Here we go. So for some reason, if the if the screen gets cluttered and you want to clear the screen, you can type in the word clear to clear the screen. There's also a keyboard shortcut that does the same thing, and it's Control L. So just hit Control L on the keyboard, and that will also clear the screen and bring you up to the top of the screen. It's very handy when you want to manage the look of what's going on in your terminal. Okay, and in this case, we're doing reading files with special characters. So the level requires us to read files with special characters, but if we try to read this file in a regular way, it doesn't work. So if we just try to cat space and cat dash, and dash is the name of the file, it doesn't work. So if at any time the program becomes unresponsive in Linux, we can use the Control-C keyboard shortcut to terminate the program. So if for some reason we're stuck in a program that we want to exit, we can just use the keyboard shortcut Control-C. So the control key on the keyboard is usually at the left and right corners of the main mass of the keyboard on the bottom, and then hit the C button, and that will terminate the program in Linux. So in this case, we're reading files with special characters. Something we need to understand about this is that file names should not include spaces, first of all. We can use underscores if we want to use spaces. For example, we can name something my file, like this, with an underscore. Number 2, file names should not start with numbers, because certain numbers are treated as special characters in Linux. So definitely don't start file names with numbers, because that can lead to some awkward interactions. And number 3, file names should never start with special characters, because there's a bunch of special characters in Linux that are treated as special commands or interpreted as special things in Linux. So don't use your special characters, your % signs, your $signs, your exclamation points. Okay, if the dash, I think the dash is an executable. Well, I mean, I think dash by itself is interpreted as like taking in input from some other location. I'm not completely sure, but the dash in this case is a no-go. What we need to do in this case, when we want to read files with special characters, we have to reference the exact directory where the file is. In Linux, the current directory is referenced with /. So cat / the current directory dash the name of the file. So if we go back in and we do cat /, which is the current directory, dash the file in the current directory, then we can read the password. So this is the password for the next level, which is Bandit level 2. We will copy it. We will go to our terminal and we will record it as Bandit 2. And we'll output this to the banditpass.txt file with our double greater than signs to append to the bandit pass file. So after that, if you read the bandit pass file, you should see 2 passwords, one for bandit 1 and one for bandit 2. Red Sly Fox, I think $sign means hidden. $sign means variable, as far as I know, in the Linux terminal. And Pretzel Pete, yeah, so dot is a hidden directory. I think we're going to be coming across this in the next, exactly in the next level. Okay, so this is the password for the next level. We will exit, and then we will log into the next level. So remember everybody, this is the SSH command we're going to use. Okay, and then we'll use our password, we'll copy it. Okay, now we're logged in. All right. Spaces in this file name. Okay, we were talking about this earlier. Let's take a look at the notes. So for each one of the levels, we should read the description that has the level goal. So level 2 to level 3. So the password for the next level is stored in a file called spaces in this file name located in the home directory. So remember what we talked about? We shouldn't put special characters at the beginning, especially at the beginning of the file names. We shouldn't put spaces in the file names. You can put spaces in the file names, and you can put special characters in the file name. It just makes for some headaches sometimes. Let's take a look at my explanation. So Bandit 2, reading files with spaces in the name. So in this level, we need to read a file with spaces in its name. If we try to read this file normally, we won't be able to, since Linux interprets the spaces as the end of one file name and the beginning of another. So if you try to cat spaces in this file name, it'll try to read one file called spaces, another file called in, another file called this, and a last file called file name. So it tries to read 4 files, but it's actually supposed to be reading 1. Rotation. Hello, nice to see you here. Red Sly Fox says, it's been a while since I did bash scripting. Yeah, me too. Me too. Thank you very much for the subscription on YouTube, Rotation. Much appreciated. We're just talking about how to use your Linux terminal. Okay, and this is why it's not recommended to put spaces in file names. However, there's a couple of methods we can use to reference file names with spaces in them. So notably, a lot of Windows files do have spaces in them, but it kind of runs across the same problem sometimes. Use the backslash as a special character. It's an escape character. Yeah, I think we talk about that in this document too. So the first method is to wrap the name of the file in quotes, so either single quotes or double quotes. This ensures that Linux will interpret everything in the quotes as a single object and not as 4 separate objects. I'm not sure if this still works because they put the dashes in the file name as well since I did my documentation on this. Let's give this a try though. So cat, and then between some quotes, spaces in this file name. Hey, hello, Peter Geens, thank you. Okay, that doesn't work. So this doesn't work if it has special characters and spaces, but if it just had spaces, this would have worked. So the next thing we can do is we can do the quotes, but we can also reference the current directory. So cat current directory, spaces in the file names between some quotes, and we get it this time. So they've changed this level since the last time I took a look at it, but this is the password for Bandit level 3. Rotation says, I just got back into cyber stuff after years. Have been using Try Hack Me. I'm still a noob, but I know some stuff. Oh, yeah. No worries, no worries. Everybody's coming from a different place. Okay, so we're going to copy this password. So this is Bandit level 3. An important thing to do when you're while you're doing challenges is to do documentation. Okay, so now we've got 3 bandit level passwords. And do I have anything else to say in here? Bandit level 2. So the second method to do this kind of challenge is to insert a / character before every space in the file name, which lets Linux know that the space is not the start of a new file name, but part of the current file name. Okay, so I think let's give this a try. So we'll go back into the level. Where was it? Oh, we're still in the level. Okay. So space in this file name, so we're just going to cat. And before each one of these special characters, we're going to put a /. So /, /, So just before every one of these special characters, we put a /. Oh, that doesn't work for this one. Hold on. Let's try... So we'll put the backslashes before the spaces, but we'll wrap everything else in quotes. And then we'll try referencing the current directory. Okay, so looks like the solution for this one is specifically wrap it in quotes and reference the current directory, like this. I added too many. Hold on. So 1 /, 2 /, 3 /. I was thinking quotes. Specify inside the path. Specify inside the path. Yeah. No. So if you use quotes, you shouldn't use the backslashes. Oh, okay. You can use the backslashes if you reference the current directory here. Okay. Alright, let's move on into the next level. Okay, so exit, and then we'll log into Bandit 3 with the password that we picked up. Paste it in. Okay, and we're now on Bandit level 3. So we're doing 3 to 4. So it says the password for the next level is stored in a hidden file in the in here directory. A hidden file in the in here directory. Okay. So hidden file in here directory. So in this level, we've got this directory here called in here. And if we take a look in here, there's a file called hiding from you in here. All right, so this is what we're talking about. We're talking about hidden files. So I think I talk about it in my presentation. Let's pull it up. Hidden file, sneaky seeky. Zamru, hey, what's up? What's up? So Bandit 3. So if you're working from perspective of being a complete beginner in Linux, this is where you actually have to learn how to change directories. Or actually, you don't need to change directories, but it can come in handy, you know. We can move into a directory by using the cd command. So the syntax is cd directory name, for example, cd in here, to move into the in here directory. Okay, if we want to check our current directory, we can use the pwd, present working directory command. In Linux, all directories start with a slash, for example, /home, /bandit, /in here directory. And in Linux, any directory or file that starts with a dot is a hidden file, which means that it won't appear when using the ls command in the regular way. So if you just use... So we'll move into the in here directory. And if we take a look, using ls, we don't see anything, because everything in here is hidden. And there's actually a couple of interesting other hidden files in here as well. So lsl will list the files in the list format, like this. And it also gets you other information like the file owner, the size of the file, when the file was created, and the file permissions. So if you're new to Linux, this is all going to look very foreign to you, but there's some good information here if you know what you're looking for. So the other thing we can do is we can do ls-a. So when we run Linux commands with dash something something, it's basically running a command with extra arguments. It modifies the command. So in this case, -a is going to show all of the files, not just the regular ones. So all means that it includes hidden files, including the dot directory, the dot directory, and the dot hiding from you file. So what are the dot and dot directories, you might ask? So the dot directory is the current directory. So the directory you're in right now is dot, and the directory that's above this one is called dot. -- help, yeah, -- help comes in handy when you need to figure out the command that you're looking at and you don't have access to the internet. But there's also dot hiding from you. So we can read this just like any other file, just cat dot hiding, and this is a good place to let you know about the tab autocomplete. So if you start typing out the name of a file and you hit the tab button on your keyboard, which is on the left-hand side of your keyboard, usually between the control key and the escape key, that will autocomplete the file name. Comes in very handy. Okay, and then we can read this. So you're going to see this a lot in beginner level CTFs specifically, but you'll see it in other CTFs as well. These hidden files. So we're going to copy this and we're going to record this as the password for Bandit level 4. Okay, and I can give you the password for Bandit level 4 here too. Okay, let's get out of here and move on to the next level. So if you have any questions about any of the stuff that they're talking about, feel free to ask questions. I don't always have the answers. I don't consider myself like an expert at Linux, but I know enough to solve these levels. Okay, Bandit level 4. Okay, so there's another in here directory. Let's take a look at the level description. Okay, the password for the next level is stored in the only human readable file in the in here directory. Tip: if your terminal is messed up, try the reset command. Okay, so how can I learn the bash terminal? Yeah, I mean, you can join us. We're talking a lot about working on the bash terminal over here. There are also like a couple of different courses you could try, and I think we've got some learning resources over here. So try taking a look at the links over here. Okay, so where was it? The only human readable file in the in here directory. So we get to learn what the difference is between text and data in this level. We'll talk about this. So cat in here, no, not cat, ls. Okay, and then there are different files in here. So there are 10 files. So we can run lsla to get, well, lsl to get information about these files. So they're, well, the other thing that's slightly trickier because these files begin with a special character, like in the second level, and we could read them all at the same time, and we would do like move into in here, so cd in here, and then cat star. Star in the Linux terminal means everything, which means it would read all the files. Oh, unexpected argument -f. Ah, okay. So the reason why it says unexpected argument found is because the -f is interpreted as an argument. I think we can do, yeah, okay. So if you do the current directory and then star, it'll read everything in the current directory without interpreting the file names as arguments. So the other thing we could do is we could run a file command. So file is a command in Linux that can be used to identify the contents of files. So file /file00 in this case. And it says that it is data. So data means that it's, there's a bunch of like non-readable bytes in the file, as opposed to ASCII text, which can be read. Bash, man bash learned. Man bash? Bash the man? Maybe. Okay, let's talk about what's going on here. So this is Bandit level 4, text versus data content. So computer files typically contain one of two types of content: human-readable text or machine-readable data. So files with data content are meant to be processed by computer software and will not be readable if read using the cat command. So if you try to read file 00, you're just going to get a bunch of gibberish because they're bytes. Thank you very much, Cyrillic Letters, for subscribing on YouTube. Thank you. Okay, in this level, we're meant to find out which file contains text contents and not binary. It would be tedious to look through the files one by one, but there's a way to scan all the files at once. So the way we do this is using the file command. So the file command in Linux is used to return the types of contents in a file, and also using the asterisk wildcard character. So this character is a special character in Linux and is used as a shorthand for all files. And we can run a command like the one above to combine the file combined with the file command combined with the asterisk wildcard character to run a command on all files in the directory. So let's go ahead and do that. So file /star. So what this does is runs the file command that we just did, but on every file in the directory. And we found some different types of file content here. So most of these say data, 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 open PGP secret key, non-ISO extended ASCII text with null-line characters, and we see here that there's one file with actual ASCII text that we can read. So we can read this file, so cat, and it's also kind of handy to be able to copy and paste these file paths so that we don't need to type them out. So highlight the file path, copy it, paste it in, and then that's the password for the next level. Okay, so let's see. Red Sly Fox says, I guess if you knew Russian, you would be NSA level hacking. Does that mean that everybody who reads Russian is an NSA level hacker? I don't know. Advow says, any recommendations for an AV antivirus product? I'm using Total AV, it's expensive. I mean, there's plenty of free antivirus solutions out there. If you're using Windows, Windows Defender by itself does an okay job. If anybody has any recommendations, let us know in the chat. Can you run the cat command on the other non-data files? Yeah, I can do that. So if I run it on data 00, it's just a bunch of gibberish. We can't read these bytes. We can actually get the exact bytes inside of these files with the xxd command, which shows the file's contents in hexadecimal characters. So the contents of this file is a bunch of non-readable bytes. Some of them are readable, but most of them are not. So these kind of files, or this kind of content, is not meant to be read by people, but rather meant to be read by machines. Can you please start all over? CyberSage, if there's something specific you want to take a look at, you can ask me questions, but I don't know if I can start all over again. Anyways, you can actually go back in the VOD. So if you loaded the VOD, you can... The best way to do it is to go to the YouTube channel and then go back. Go back like 20 minutes or so. Or like 40 minutes, and then you can start from the beginning. Orion Mathis says, I use Sophos Home AV. It's like $60 a year for like 10 PCs. They also do enterprise level AV, but are very proud of it in their pricing. Oh, really? Should I even use Bitdefender? Bitdefender, is that the hard drive encryption thing? Okay, let's record the password for this level. So that's Bandit 5. Okay, and we'll move on to the next level. Here's the password for Bandit 5. That's BitLocker. Oh, okay, Bitdefender, is that, let me look it up. Oh, Bitdefender is an antivirus program, okay. Can you cat command the OpenGPG and the extended ASCII thing? Oh yeah, sure. I can, hold on. Yeah, let's go back to Bandit 4. Okay. Okay, so you wanted to take a look at the stuff that was labeled as the open PGP whatever, what is it? So open PGP secret key. So secret keys are keys that are used for encryption and decryption using this system called open PGP. So, I mean, we can read it, but it's probably not going to be human readable. Yeah, so it's just a bunch of bytes, non-readable bytes. And the non-ISO extended ASCII text. So here, it's probably just stuff that's in the extended ASCII list. A bunch of characters that we can't normally read. Okay, Sina, why are you saying that? Could run strings. I mean, we could run strings on that file. Strings with an S. Actually, we'll talk about strings in another level. Probably the next level. Let's log into Bandit level 5. Okay, we've got another in here directory. Oh, this is where we need to use the find command. Okay, so there's a bunch of directories in here, and there's a bunch of files in each one of these directories. We need to find a specific file. Let's talk about it. So this is 5 to 6. Okay, so the password for next level is stored in a file somewhere under the in here directory, and has all the following properties: human readable, 1033 bytes in size and non-executable. So what we need to do is we need to use a pretty common utility tool in Linux called the find command to find a specific file that has all these characteristics. Okay, so this is Bandit level 5, and in this level we're using the find command. So the find command is used to search for files on the system. It can be used with many different arguments and flags to refine its search parameters. The find command allows a search of files and/or directories in the file system, and it matches files in the output according to the criteria provided by the command arguments. For example, the argument type searches for file or directories, and the argument size searches for files of a particular size. Yeah, it's a very useful command to know. Okay, so find type F. So in this case, we're looking for a file, not a directory. So what we're going to be using in this level of the game is a find command that is very specific. So find dot, and dot is, 1 is the command itself, 2 is the dot, the location to be searched. So remember in Linux that the dot refers to the current directory. Number 3 is the size of the data to be returned. So this is dash size, and we're looking for a file of 1033 bytes, which is denoted by C when we're using the find command. Okay, and then the executable status, dash executable, and we put a exclamation point in front of it, which means not. So not executable, size 1033C, find in the current directory, which is dot. Okay, let's run the command. Find dot size 1033C and not dash executable. Okay, and it identifies the exact file. So dot may be here, 7 / dot file 2. So this is a hidden file as well. If we wanted to read this, the easiest way is to copy the exact file path and just run cat and paste in the file path. Okay, you could also specify dash not. Oh, I didn't know that was an option. Hold on. So dash not executable. Oh, awesome, awesome. You can use dash not instead of the exclamation point. But yeah, either way you do it, you locate this file, and if you read it, you get the password for the next level. Why is there all this blank space in here? Alright, copy the password. So remember, if your terminal gets weird looking, you can always clear the screen by typing in the word clear. Okay, so we'll record the password for Bandit 6. Move on, and then we'll move on to the next level. Okay, so everybody, Bandit 6, it's over here. Okay, we'll exit the level, and then we'll log into Bandit level 6 with SSH. Paste in the password. Okay, we've got an ad running on Twitch right now. So when ads run on Twitch, we will take a little break and put on some birds. I love my birds. Check out these ones. How often do you stream? 4 times a week. 2 short streams and 2 long streams. Okay, Blow My Mind says, soothing birds. Yeah, I've got the birds outside my window. So it's fun to watch. It's a fun little distraction sometimes. Cypher says Control L will also clear. That's correct. So if for some reason you want to clear the screen, you can do Control plus L on your keyboard, and that will clear the screen. Or you could just type in the word clear. What type of birds are they? Yeah, they're northern flicker woodpeckers, Mr. Ferguson. Let's pull them up real quick. Northern flicker woodpecker. Stop fighting. So these guys are very cute. They're a beautiful bird that usually has either a black mustache. Well, the males have a black mustache or a red mustache, depending on which region of the country you find them in. And they all have this beautiful plumage. It looks very, 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 very nice. A very lovely view you have outside. Yeah. I don't usually see the woodpeckers. The woodpeckers are usually eating ants. They usually use their really long tongue to eat ants. But sometimes when there are no ants, they'll eat peanuts. Anyways, level 6. So the password for the next level is stored somewhere on the server and has all of the following properties. Owned by user Bandit 7, owned by group Bandit 6, 33 bytes in size. So this is another grep challenge, and they don't tell you where the file is. It says it's somewhere on the server, so it could be anywhere. Let's talk about this. So Bandit 6 find command, this is a much longer find command that has that'll get you what you're supposed to be looking for. So find the command itself here, to the location to be searched. So in this case, we're searching the entire file system, and the entire file system is referenced with the slash by itself, just one slash by itself. So the type of data to be returned, either a file or directory. So we're looking for type F here, so dash type F. The file directory user ownership, and in this case we're looking for files that are owned by Bandit 7. So dash user Bandit 7. The group ownership is dash group Bandit 6. The file directory size is dash size, and in this case it's 33C. And omit error message from the output, it's 2 greater than dev null. Okay, so we'll talk about this as we create the command. Find slash type file dash user Bandit 7 dash group Bandit 6 and size. So size 33C for bytes to dev null. So the reason why we put this portion of the command onto the end of it is that it redirects the error messages. So 2 is error, so standard error. We redirect that into the dev null device. So the dev null device is basically, you can think of it as a trash can. So it's basically nothing. So we redirect the error messages into nothing, so we don't see them. Okay, when we run the command, we get this file. So Bandit 7 password. We will copy the file path and read it. Okay? So this is actually a very useful thing to tack on to the end of your commands if you suspect that you're going to see a lot of error messages from running the command. Gina Don says, when you find the password, can you talk about how the command find works? Because I did not understand how a command can be this long. So I mean, the command is this long because it's very, very specific. So some commands can be very, very long. You just have to get used to seeing this kind of thing. Okay, so we got the password, and we break down the command over here. Typically commands are not super long, but you know, depending on the type of command being used. Run it without error elimination, please. Yeah, I can demonstrate that. So let me record the password first, and then I'll show you what the command looks like without the error elimination. So this is for Bandit 7. Okay, so if we run the command without the errors, we'll probably see a bunch of errors because we're trying to access files that we don't have permission for. So it'll say like permission denied a bunch. Yeah, so it says permission denied on a bunch of different files here because our user doesn't have permissions for these files. So if we want to not see these error messages, we just tack on the to_dev null onto the end of the command. To greater than dev/dev/null. You could also do grep. I mean, we could we do grep for this challenge? I mean, we could run find and then we could redirect it into grep maybe. But if we didn't know, I mean, the thing is that we have to know the name of the file. If we didn't know the name of the file, we couldn't use grep. Grep Bandit 7? I mean, what if the file doesn't have the word Bandit 7 in it, though? We need to know a lot for grep? Yeah, we need to know a lot for grep as well. Alright, let's move on to the next level. Okay, next level. Pipe it? I mean, the point is that if we don't know the name of the file, we couldn't use grep. We could only use grep if we already know the name of the file. You're looking for the Bandit 7 password. You're looking for... We don't know. We don't know this information beforehand. We're looking for the Bandit 7 password, but we don't know. Even if we grep for Bandit 7 password, maybe the file doesn't have the word Bandit 7 password in it, right? Okay, so Bandit level 7. So what's going on here? So level 7 to level 8. Can you try it? Okay, so we should be able to find slash user bandit 7. And the size is going to be 33 bytes, right? Okay, so this is the file that we're looking for. But you're saying that we're supposed to grep for what? Grep for Bandit 7. Well, we would need... it doesn't exactly work, because it also gives us all the error messages. We'd need to, like, look through for this. The other thing is that the file that with the password doesn't necessarily have the word Bandit 7 in it. We just know because we solved the challenge already. Sparkling Sylveon, hello, nice to see you here. What is up? Okay, let's so this is Bandit level 7. Let's do the level. So the password to the next level is stored in the file data.txt next to the word millionth. So the file data.txt next to the word millionth. So the first thing we need to do is we need to find this file data.txt. I think it's in our current directory, right? So data.txt, if we try reading it, it's just got a lot of data, and we need to find a way to parse through the data in order to find the word millionth, because it's telling us that the password is next to the word millionth in the data.txt file. So for this level, we're going to use the grep command. So the grep command searches within the contents of files for specified strings. It is very commonly used to pick out specific words or phrases. Ginadon says grep is used to find strings, aren't they? Aren't you using it to direct errors into another file? Filter the file specifically by the word millionth and how many times it appears. I mean, I don't think we need to do that for this particular level. But yeah, grep. So the grep command we're going to be using is very simple. It's just going to be grep, the command itself, to millionth, the pattern to search for in the file or directory, and then 3, data.txt, the file to be searched. So grep, pattern, file. So in this case, we're going to grep millionth data.txt, and it's able to find the word millionth inside the file, and beside it, this is the password, because that's what was described in the level description. Okay, Sparkling Sylveon says, filter the file specifically by the word millionth and how many times it appears. I mean, it actually only appears once. and anyways, let's record the password for the level. Okay. Copy the password. Bandit level 8. Okay, so for people who want to try this out themselves, Bandit 8, this is the password. We'll log out of the level. Then we'll log into level 8. Okay, and then we'll paste in the password. And there's another data.txt. Okay. Alright, so just a second, let's take a look at the level for the level goal. So 8 to 9. So the password for the next level is stored in the file data.txt and is the only line of text that occurs only once. Okay, so this is what Sparkling Sylveon was talking about, because they were talking about sorting the data by how many times it appears. Let's talk about this. So we're using a couple of new commands. So in Bandit 8, we're going to be using the sort command. So the sort command takes all the lines contained within a given file and returns them in alphabetical or numerical order. So in this case, we're running the command itself, sort, and then the input to be sorted, which is data.txt. So when we run this by itself, so sort data.txt, it just gives us the output, but what we want is we want the number of times each one of these lines appears. Yeah, did this a while ago, got to level 13. I mean, you learn a lot of good little tricks by finishing the bandit levels. Okay, so the next thing we have to do is we need to use the unique command. So the unique command takes all of the lines in a file and removes any lines with identical contents to the ones above it. This command is very useful for removing consecutive blank lines in a given file, and we can combine these, the sort command and the unique command. And in this case, yeah, we're going to be using unique-c to get a count for how many times the line appears. So the command itself is unique, C is the count flag, and then file is the file to be processed. So in this case, we also have to do something called command piping. So command piping is, it might be a new concept to you, but it's a very common thing you do in Linux. So in Linux, command piping is the process of passing the output of one command into the input of a second command. So in this level, we're going to be sorting data.txt, and then the results of that we're going to pipe, which is to supply that output as the input to the next command, which is unique-c. So this is a very useful feature because it allows commands to be chained together to achieve a lot of flexible output. So we run the first command here, and then we pipe it into the second command. Okay, let's go ahead and do that. So we sort data.txt, and then, so remember, you can also get command history in the terminal. You push up and down on the arrow keys, and that'll bring up the previous commands you've run. It is very, very useful, and on terminals where you can't get the command history, you're usually very sad. Okay, Sylveon says, I'm a bit daunted by piping, but I guess anything that comes after that is ran is in the sequence simply. Yeah, so you just need to think of it as... So let me show you an example. So here, let's just say we do cat bandit pass. So this outputs bandit pass, and then we want to pass this information to another command. So if we cat bandit pass, and then we pipe, and then we pass it to the rev command, which prints everything out backwards, we're basically giving this output to the reverse command. So basically print everything in reverse. And we can also like pipe multiple times. So cat bandit pass, rev, and then base 64 encode something, or like hash everything, say. So we do MD5 sum to get like a file hash for this output. Piping is a very powerful it's a very powerful technique we use in Linux terminals when we're running commands. You just need to get used to it. Control R is also very useful. Is Control R reset? I'm not too sure. One command after another. Yeah, basically. Commander Soul, Comrade Soul. Hey, what's up? How are you doing? Okay, so let's go ahead and finish this level. So sort data.txt, pipe it into unique-c. So this will get us a count of, well, it'll give us a count of the different lines. So this line happens 10 times. So if we scroll all the way up to the top, well, we don't scroll all the way up to the top. So, okay. So we want to get the only line that occurs only once. So we can actually pipe this again into sort. And this will get us these results, but sorted again. So this is the only line that occurs once, so this is our answer. Please put all the useful commands in your GitHub for later reference. Control R searches backwards in history. Oh, does it? I don't think I've used that one before. But it sounds like a pretty useful keyboard shortcut for sure. Okay, so let's go ahead and record this, and then we'll move on to our lesson. I think we talk about grep and stuff in the lesson as well. If we have time, we'll come back to our bandit levels. Okay, we'll just exit out of here. Alright, so we're going to take a little break before we do the next part of the stream. So we're doing topic 3. We've got topic 4 on deck. But before we do it, I need to take a little break, maybe 2 minutes or so. But while the break is going on, I'll show you the birds. Okay, these are more woodpeckers. We'll be back in about 2 minutes, okay? See you in a bit. Okay, we're back. Alright, so Yasin Gesmi says, can you hack Google Chrome to delete my search history, please? I think you can delete your search history yourself. I don't need to hack into your system. And you know, that's not what I do. Okay, let's put the birds away. Let's get back to the hacking. Mr. Ferguson says, the background sounds like villain and hero fighting themes. Yeah, this is Mass Effect 2. So if you know the science fiction game Mass Effect 2, it's got a very cool soundtrack. And that's what's playing right now. Alright, so we're going to be doing some HackerFrogs AfterSchool. It's a little program that I came up with. And we're going to be talking about more Linux stuff. Where'd I put that? Oh, thank you very much for the follow on Twitch. Tearing Tubble TV, thank you. Okay, hold on. Alright, so this is HackerFrogs AfterSchool. It's a little program I came up with to teach beginner cybersecurity skills across a wide variety of subjects. This is the second intro to Linux OS Operations workshop. In the previous workshop, we learned about the following Linux commands. We learned about the ls command. So ls, this command lists the files and directories in the current directory. It can be used with the -l argument to output in a list format, and with the -a argument to include hidden files and directories in the output. These two arguments can be combined to produce both outputs. For example, we can do ls-la to get both of these arguments. So if we were to run lsla in a typical Linux directory, you'd usually see everything listed out in a list format, and it would include hidden directories like the dot and dot directories. We also learned about the cat command. So the cat command lists the contents of a file. The name of the file to be read must be supplied as an argument to the command. For example, cat example.txt. The cd command changes the current directory to the one specified. The new directory must be supplied as an argument to the command. For example, cd space downloads will move you into the downloads directory. Okay, we've got the pwd command. So pwd stands for present working directory or print working directory, and it lets you know which directory you're currently working inside. We learned about the file command, which identifies the type of contents for a specified file. So the file name must be supplied as an argument to the file command. Okay, Sylvian says, is it ever suboptimal to just always either run ls or lsla versus lsl or lsa? I mean, typically I'm always running the ls command with the la, because I'm usually trying to look for specific file permissions and like hidden files as well. But yeah, sometimes you just want like less stuff on the screen, so you just run ls by itself. Okay, let's continue where we left off. So over at the picoctf website, so it's not exactly picoctf, it's now called Scilab. So let me grab the link for the website we're going to be using. So it's called scilabacademy.org. And if you don't have an account over there, you can make one for free. It's a very, very good website for learning about different cybersecurity concepts. The thing we have to keep in mind is that the site needs to load. Just a second, everybody. Huh. Is Scilab Academy experiencing some sort of... It timed out. That's weird. Okay, Scilab Academy. Can anybody else access Scilab Academy? Let me know if it's just me. Okay, okay. we can log into the account. Cloudflare, yeah. Man, this it seems to be pretty unresponsive today. I wonder if there's like regular maintenance being run. Scilab Academy maintenance. It doesn't say there's maintenance being run. Oh, yeah. So, connection timed out. That's no good. Also still loading, yeah. It looks like Scilab Academy isn't having a very good day. Actually, let me take a look at what we're supposed to be learning today. Maybe I can adjust it. So we're doing session number 2. You have to pay? No, I mean the website is free. Okay, so we're basically running through the find command. I mean, this was also done on the Bandit levels, so we can cover this inside of. So they talk about find, they talk about grep, big zip, Magikarp Grand Mission. I think we can do this on Bandit instead of using Scilab Academy because it's not responding. Okay, that's fine. We'll do Bandit instead. So I think the level of Bandit we're looking for is... Hold on, let me look it up. So the same kind of stuff, we can find it on Bandit level 4. Let me get the password for that, for you all. So what I want you to do is I want you to use your Linux terminal to log into Bandit level 4. Here are the credentials. Is find good for metadata stripping, or would EXIF tool be needed? I mean, I'm not even sure if I'm not even sure if you can strip out metadata using the find tool. Okay, so use these credentials, Bandit 4, and then after the colon, that's the password. And you want to use this command right here. So the command is ssh bandit4 at banditlabs.overthewire.org. So if you don't have a Linux terminal to use, I can point you towards a resource over here. Still not loading up. Okay. So it's called JS Linux, and it's a Linux virtual machine that you can use from this website. So you can load this up. I'll demonstrate. So if you don't have a Linux terminal to use, you can load up this website and I'll give you a Linux machine that you can use for these exercises. So you would grab the SSH command that I put into chat and copy it. Then you would paste it in here and then hit the enter key. So the connection for these machines is actually not all that fast either. So it's going to ask us if you're sure you want to continue connecting. The answer is yes. Hit enter, and then it'll ask for the password. So copy the password that I put in chat. So everything after the colon, copy it, and then paste in the password. When you paste it in, you're not going to see anything. That's normal. Just hit enter, and that'll log you in. So after you're logged in, you probably want to clear the screen, so type the word clear into the terminal. Of course, if you have your own Linux terminal, you don't need to use something like JS Linux. It's just something for people who don't have a Linux terminal to use. So I'll continue the rest of this demonstration from my own terminal instead. because my own terminal looks much nicer. Okay, so after you're logged in, the goals for this level can be found on this web page over here. So for each level of this game, there's a goal that you need to do to get the password for the next level. So for this level, it says the password for the next level is stored in the only human readable file in the inhere directory. If your terminal is messed up, try the reset command. Okay. So we're going to be talking about some other commands as well, some other useful commands that that you can use while you're using your Linux terminal. So the make dir or make directory command is very, very useful because it lets you create new directories. Mac terminal okay? Yeah, I mean if you're using a Mac terminal, you can still use SSH. It should be fine. Can you modify the terminal colors in JS Terminal? I mean, I've never tried. Maybe you can. I've never tried it. So the make directory command. So when solving challenges, it's very useful to create new directories and work within them to keep the rest of your file system organized. So to do that, we're going to use the make directory command, so make dir. So the make directory command is used to create new directories in the current directory. The syntax for the command is as follows. So make directory, new directory name. So for example, make directory first find, or whatever you like. So while we can't really do it inside of the Bandit game because it doesn't let us create new directories, but if you've got your own Linux terminal, so for example, you're in the temp directory, you can make a new directory in here. So make directory HackerFrogs. Okay, and then we see that there's a new directory called HackerFrogs in here that we can move into. So cd HackerFrogs. Print working directory, it says we're in temp HackerFrogs. But yeah, most of the time you want to keep your challenge files and basically everything has to be separated away from each other, otherwise you'll end up with like a really big mess. Okay, and another useful command is the whoami command. So the whoami command is used to return the name of the user account currently being used. So if you type in whoami, you'll usually get you get your username. So in my case, my username is the Shy Hat. If you go over to JS Linux and we're doing the Bandit CTF game and we do whoami, wow, why is this so ugly looking? Hold on. Let me see if I can reset this terminal. It doesn't really want to cooperate with me today. Okay, for some reason, when we're using this terminal, it prints out all this stuff after we do each one of our commands. So maybe this isn't so good for us today. Scilab Academy is still not responding. I just get Bandit 4. Yeah, so Bandit 4 is what you're looking for. So who am I? Bandit 4. So there's generally two types of user accounts on Linux machines. User account names. So in CTF games, you usually have control of a specific user account. For example, Bandit 4. The other important account name you should pay attention to is the root user account. So the root account has complete control over the entire file system. So you don't really need to know very much about the root account right now. You just need to understand that if you have access to the root user account, you have complete control over this file system. So that's the whoami command. So here the whoami command is used, and the name of the account is the shyhat picoctf. So this is what we're going to be learning about for this level, so the find command. So the find command allows for the search of files or directories in the file system, and matches files in the output according to the criteria provided by the command arguments. So the argument name searches by the name of the file. Okay, so find dot the name itself. So sorry, find is the command itself. The location to be searched is dot, which is the current directory. And we're searching by name in this case. So name and the name of the file defined. So ubersecret.txt. This is not the case for this particular exercise because we're supposed to be working on another challenge called first find. But for Bandit, they've got their own criteria. So the password for the next level is stored in the only human readable file. Oh wait, never mind, we're not doing Bandit level 4. We're actually supposed to be doing Bandit level 5. Hold on. Yeah, we should be doing Bandit level 5. Sorry everybody, let me get the password for Bandit 5. It's a good thing we did these Bandit levels before we started our lesson today. Otherwise we wouldn't have the passwords. Okay, so one more time. So we're doing Bandit level 5 to level 6. So in this level, level 5, the password for the next level is stored in the file under the inherent directory and has all the following properties. So human readable, 1033 bytes in size, and not executable. So we can look for a file that is just like this. Sylvian says it's easy to get them again quickly, as most of them build on each other. Yeah, most of them do build on each other. It's just it would be time consuming is the problem. Okay, so find command. In this case, we're going to run this one. So the command itself, find. The location to be searched is dot, which is the current directory. The size of the data to be returned, we're going to specify -size, so 1033C, which is bytes. Exclamation point means not, and executable. So we're going to go in, find dot size 1033C for bytes, not executable. Remember everybody, you need to spell everything correctly when you're typing in your commands. Okay, and we discover a file, and we can copy the file path and read it. So just copy, type cat, paste in the file path, and that's the password for the next level. So this one over here. Okay, so the other thing is we can try looking for files that that have all sorts of criteria, right? So for example, we can start looking for files in the entire file system, which is the slash over here. And we can start looking for stuff has a specific name. So the specific name is going to be password. So this is going to retrieve the password file for the system. And we're also going to redirect all of the error output to the dev null device, which basically is going to not output error messages, because typically when you search in the entire file system, you're going to come across files that you don't have access to, and that's going to produce an error message. But if you run your command like this, then we're going to get all of the files that have the word password in them. So for example, etc pamd password, etc password, user bin password. And if we were to read this, it's also a very common file inside of Linux. So cat etc password is going to get you all of the user accounts for the system. And there's a lot of user accounts on this system. There's a user account for every level of every game on the server, along with all the other service accounts. But this isn't what we're looking for. We're just looking for a way to search for specific files. And we'll do that more in the next level. Actually, we might skip we might skip a couple levels. Okay, so where were we? So that was the find command. So another thing we need to keep in mind is the rm command. So to keep our picoctf web shell, well, it's not the picoctf web shell, but our file system, to keep it clean, we're only, and because we're only allowed a certain amount of disk space, especially if we're talking about the picoctf partition, we should delete our challenge directories after we're done solving the challenge. And we can do so with the rm command. Sivian says, I've always explored that, and I thought there were alternative paths to hack your way through. Well, I mean, most of the time, sometimes there's more than one solution for these CTF challenges, and sometimes there's only one. Okay, so the rm command. This is another very important command, because it lets you delete files. So the syntax for the rm command is as follows: rm space file name. But deleting the directories requires the use of the -r flag. So rm-r first find, or whatever directory name. Let's demonstrate this. So let's do this from our temporary directory here. Okay, so in my temporary directory, I've got my HackerFrogs directory here, and let's suppose we want to delete it. We would do rm-r for recursive on HackerFrogs. And then after we run this command, the HackerFrogs directory is no longer here. So we can make a directory, we'll call it anything, and we can delete it with the rm command, remove. So rm-r, anything, and that deletes the file. Okay, so the next thing we're going to do is we're going to learn about using the grep command. So, darn it, Scilab Academy. Okay, we can do this one using Bandit CTF as well. So let me find the Bandit CTF level where we do this. So this is Bandit level 7. Okay, so everybody, I'll give you the password for Bandit level 7. Here it is. And the command to run to access the level is this one right here. Okay. So copy the password. Make sure you don't copy the colon. Paste in the selection, hit enter, and then you're logged into the level. So what's the goal for this level? So this is level 7. Okay, it says the password for the next level is stored in the file data.txt next to the word millionth. So we need to pull the word millionth out of the file, and we need to find what's next to it, because that's the password. So the grep command searches within the contents of files for specified strings. It's very commonly used to pick out specific words or phrases. So, for example, let's just say I'm in my... Let's read the etc password file. So this file has all of our user accounts. And let's say we're only interested in the lines that have the word vortex in them. Or maybe bandit. We're looking for only the lines with the word bandit in it. So we can run grep for the pattern bandit on etc password. So grep, the name of the command, the pattern we're looking for, bandit, and then the file we want to search inside, so etc password. And it finds all the lines with the word bandit on them. So this isn't what we're looking for in this level. We're actually looking for the word millionth inside data.txt. So we run grep space millionth space inside of data.txt. And beside this word is the password for the next level. Okay, so the thing that they're trying to illustrate with data.txt is that there could be a lot of content in each one of these files, and we want some ability to be able to pull out specific patterns. I often see examples of grep with pipe. Yeah, that's true. We'll talk about that. So we haven't really introduced piping yet, but I guess this is as good a time as any to introduce piping. So if, say we wanted to cat password or etc password. So slash etc slash password. And we've got all our user accounts here. What we could do is we could run cat, and then we could pass the output of cat into the grep command. So we use the pipe command here. So pipe is a character that is the shifted backslash on your typical American keyboard. On European keyboards, it might be different, but the character looks like this. You do pipe and then space, and then you run your second command. So in this case, we're going to grep. So you type grep and then the pattern you're looking for. So in this case, maybe I want to look for the root user. And that outputs only the line in password, the output of password, cat password, that has the line root in it. So if we're looking for other patterns, we could look for stuff like bandit, or we could look for, say that we're only interested in the word git in here. We could also grep for git. And we get just the output that has the word git on it. Okay, so that's grep. Grep is a very useful command. You're going to be using it often if you work inside of the Linux terminal a lot. Okay, so the next challenge is supposed to be the Big Zip Challenge. Oh, I think this is another... Hold on. Is it working now? Okay, so everybody else in chat, if you're able to access Scilab Academy, load up the website, let me know. Scilabs is having a bad day. Otherwise, we can solve more challenges inside of Bandit. In fact, let me take a look at some of these levels of Bandit. Maybe we can improvise the next challenge. So command piping. Okay, let's just solve some more levels on Bandit to talk about more concepts in Linux. Okay, you're in Scilab now. Okay, is it working again? Okay, is it working? If it's working, we can actually use Scilab. All right, so it looks like Scilab is working again. So let's get that big zip challenge. If you're having... So let me know, everybody let me know if you can load up this page. So you'll need to be logged into Scilab to access this. But if you're logged in and you can access this page, let me know so that we can continue on with doing these challenges. So the big zip challenge. So the challenge description here says unzip this archive and find the flag, and it says download zip archive. So from here, still loading. Really? Okay, Sylvian says I'm here. Yeah, that's... Okay, let me see if I can reload this page, and maybe it will give me the runaround. It seems to be loading okay for me now. Try reloading the page. Also, make sure, before trying to access this page, make sure you're logged in. Okay, so while we're using Scilab, we can actually use the Scilab interface, so the Scilab CLI. It's much easier because everybody's got access to the same stuff. So once you arrive on this page, click on the orange Open in Workspace button, and this will open up a terminal we can use to solve this challenge. Okay. So here we are, we got the challenge, we got our terminal, and we can also put this terminal inside of full screen. So to do that, you right click into the terminal, you select this frame, and then you select Open Frame in New Tab. So this will put the web shell in its own browser tab, which is much easier to look at because you have a full screen to use. Okay, and then from here, we're going to make a directory to solve this challenge. So make directory big zip, like that, and then move into the directory. So after you've done that, pwd, it should say that you're in the big zip directory under your name -academy and then /home. So from here, after we're in the big zip directory, we can download the file we need to use. So back at the challenge, there's a link. So it says unzip this archive and find the flag. So highlight, or sorry, mouse over the link, right click, select copy link. Then in the web terminal, type in wget. So remember, wget is a command that is used to download files. It's very convenient for downloading internet files. So wget space, right click, paste, and this will paste in the file address for the big zip files.zip file. Okay. After you've done that, hit enter and it'll download the file. Afterwards, you should see big zip files.zip in your current directory. Okay, if there's anybody catching up with what we're doing right now, let us know, and we'll see if we can wait for a second or two. So otherwise, we can unzip this file. So we can use the file command on big zip files. It says it's a zip archive data file. And what we need to do is we need to unzip it. So these archive files, we can decompress them by running the unzip command. So unzip space, big zip files.zip. Remember, you don't need to type out the entire file name. So just start typing out the name of the file and then hit the tab key on your keyboard. It'll autocomplete. Run the command and it prints out a lot of stuff. So here's the thing. We need to look for the flag in this case, not a password, but a flag. And in picoctf, the flags have a very specific format. Let me talk about this. Oh, not this. So picoctf /scilab challenges. The goal of the exercises is to retrieve a flag. So the flag is a secret piece of text, and it has a standard format. So the standard format for flags in picoctf, it's going to be picoctf and then curly brackets, and then some data or some text. In here. Okay, so picoctf, this is the pattern we're looking for. So some text in here, and what we can do is we can look for, well, first of all, we can either look for the flag itself. So it might be in this form inside of one of the files, or we could look for a file called flag.txt. A typical file that contains the flag might be called flag.txt. So we can search for flag.txt as the file name, or we can search for the pattern of the flag, picoctf, and then open bracket to solve the challenge. So if we're looking for this, the pattern, we would be using grep. So grep for the pattern, and find for the file name. So if we use grep, the command might look like grep recursive current directory, and then the pattern -e, the pattern picoctf with the open bracket. And if we're searching by the file name, it would be find dot or current directory -name flag.txt. So this is probably the easier thing to look for, just a file called flag.txt, or we could look for the pattern inside of all the files in the directory. So we'll try both. We'll look for flag.txt, and we didn't find a file called flag.txt. We could also look for the picoctf pattern. So grep recursive, which means look inside of every file for this pattern -e, picoctf. True hacker terminal. I mean, it's got to be neon green on black, right? Nice to see you, hacker man. Okay, we found it. So we found inside of this file here, information on the record will last 1 billion years, genes and brains and books and code, picoctf, grep is magic. So we weren't trying to use find, we're trying to use grep in this challenge. Okay, so we'll copy this over, and then we'll submit this as the flag for the challenge. So the pattern holds true, picoctf, and then open bracket, close bracket, then a bunch of stuff inside. Is this picoctf from this year? I think this picoctf is from a few years ago, so maybe like 2021. Okay, we can go back to the challenge, and then we can scroll down, and in the flag submission field over here, paste in the flag, click on submit, and it says correct flag, we're finished. Okay, so if we're finished, we need to clean up after ourselves. So we've got this directory we created here called BigZip. We'll just back out. If you want to go back to your home directory instead of the Linux terminal, so you do cd and then by itself, or you can do cd tilde, which is the shifted version of the backspace key or the backtick key. But this will do the same thing. It'll bring you back to your home directory. In my case, it's home, the Shy Hat Academy. And there's a directory called BigZip that we want to delete. So rm space r for recursive, that means it'll work on directories and not just files, on BigZip. That's an interesting platform. What is it? This is Scilab Academy, which is what picoctf turned into. Okay, after we run this command, we see that the BigZip directory no longer exists. The easiest way to delete the current directory? I mean, I don't know if you want to. Yeah, I don't think you want to do that. Don't use that command, please. So rmrf / well, they probably won't let you do it on the system. They're not going to let you do it on picoctf. So rmrf / it is dangerous to operate recursively on the root directory. Use no preserve root to override this failsafe. I mean, we wouldn't be able to do it anyways because we don't have user permissions on this system. Only the root user would have the permissions to do this. Anyways, let's continue. If you have any questions about any of the stuff that we're doing, please let us know. We'll try to answer your questions as best we can. I think there is one more challenge we're going to do. So BigZip, running grep recursively. So grep can also be used to search inside of all files in a directory and all directories in those directories. This is called recursion. We need to use the -r flag, so grep -r pico, look for the pattern pico, and then dot. Looks in all the current directory and all directories under underneath for the pattern pico. Try it on a modern distro. I guess the real CTF is breaking out of the container. I mean, if you can find a way to break out of the picoctf container for their web shell, they'd probably want to know about how to do that. Okay, so let's wrap up by solving a challenge that will test our file system navigation skills, so ls and cd commands. It's called the Magikarp ground mission. Let's bring it up. So we're just going to exit the workspace. I'm going to search for this one. It's called Magikarp ground mission from picoctf 2021. Actually, so Hackerman was asking about the previous challenge. So BigZip. And this is from, they don't say which challenge it's from. This is probably from, like a challenge library exclusive. Yeah, it is an exclusive. So it's specific, it's not associated with any specific event. Okay, but this is Magikarp Grand Mission. Let's get you the link. Okay, so the challenge description says, do you know how to move between directories and read files in the shell? Start the container, SSH to it, and then ls once connected to begin. So we're going to combine a few different concepts that we've learned previously. The first thing you need to do is you need to click on the Launch Instance button, and this is going to launch the virtual machines that have the challenge infrastructure. So after you've done that, they're going to give you some information that you can use to SSH or log in to the challenge. So this is the information they give us. we need to parse out the information to create a command for SSH. So SSH, so our username is CTF player. And the place we're going to log into is willycourier.picoctf.net. And there's also a specific port number that we need to keep in mind as well. So I think I'll give everybody access to mine. So this is the SSH command you would use. Actually, I think I don't want to give everybody access to mine, because if you got access to mine, you could start messing around with the environment. Okay, so what you would want to do is open it up in the workspace. Okay, so when you use the SSH command, they're going to ask, are you sure you want to continue connecting? The answer is yes, and then the password is the password that you got from the challenge over here. Where is it? Okay. All right, everybody. So the first part of the challenge, there are 3 different parts of the flag here. So there are instructions to get to the next part of the challenge, and there's also 3 parts to the challenge. Yeah. Okay. So
Mr. Hat, may I please be excused from class?
Well, Kyle.
Yes.
You hear me? You go to
Hack.
You go to
Hack.
You
Have a great day.
have a great day, Zamru. Thank you very much. Okay, let's talk about what we're supposed to be doing in this challenge and the concepts we're supposed to understand. Okay, so there's a couple of new concepts we need to understand for this challenge. The first one is going to be we're hacking Mr. Hat. The first thing we need to understand is something called the home directory. So each user on a Linux system has a space where they can store their personal files. It's located at the /home directory /username. For example, /home/the shy hat for my home directory. So there's another concept called the top level directory. And the top level directory of a Linux system is the / directory. So just /, it's where we can find all the other directories and files on the system. And it can also be called the root directory, which can be confusing since there's another directory called the root directory. So for example, if you go over to any of your terminals and you do ls/la/ by itself, this is the directory with all of the other directories inside of it. So this is the very top level directory. And it's got all of the typical file systems, or the typical directories for the Linux file system. It's the root of the tree and the root directory. Yeah, I mean, I find it a lot easier to think of the top level directory as the top level directory instead of the root directory. But that's just me. Okay, so let's go ahead and go back to the challenge. So there are 3 parts of the flag in this challenge. So when we log in, so this is the contents of the flag. We need to copy it and we need to put it somewhere safe. I mean, we can paste it somewhere. Trees are a thing you see more often, rooted and unrooted variants. I see. Zammer says plain / is the root of the file tree. /root is the home directory for the root user, who is the root of the user hierarchy. Yeah, I guess that makes sense. Okay, so there's also this instructions to 203.txt. So we'll just try running the cat command on that. So it says, next go to the root of all things, more succinctly, /. So typically to go to the top level directory, you would do cd/, and then afterwards, when you do the pwd command to get the name of the directory that you're in, it just says /. So in here, you've got all of your Linux file system directories, and we'll talk about what's in these directories in another session. But for right now, all we need to understand is that there's 2of3flag.txt, this file in here, that we can read. Whoops. We can copy this, and then we can put it somewhere safe. So if the guitarist of Guns N' Roses had a home directory, would it be /home/? Yeah, I guess it would be. Okay, so let's read the next instructions. So cat instruction to 3of3.txt. Remember, you can use tab autocomplete to autocomplete the name of the file. Okay, lastly, CTF player, go home. More succinctly, tilde. So we're talking about the home directories. Remember, you can run the whoami command to get the name of the current user. So it's CTF player. And we can move to the tilde directory, or the home directory /home /CTF player. If we just go to the home directory, we see there's only one directory in here, which is CTF player. We can just move into that directory. Okay, and HexShoe S3, hello. Nice to see you here. Okay, so when we go to the home directory for CTF player, we see that there is a 3of3flag.txt flag in here. So we just need to copy the rest of this. So I recommend everybody to use their own credentials for doing this challenge, because this flag is not going to work for you. Let me explain why. So in most of these CTF challenges, they personalize the flags. So even if most of the flag is the same between different users, the last part of the flag is a hash of some sort, which is individualized to each user. So if you try to submit my flag, and the flag is only different because of this last little part over here, it's not going to register as correct. You need to do your own challenge, and it'll give you your own personalized flag. PC Aviator, hey, nice to see you here. What is up? Okay, let's go back to the challenge. We will paste in the flag, and then we're done. Sylvian says, that's cool about the flag. Is your progress recorded for this platform? Oh, the CTF stuff takes me back. Oh, does it? Are you a cybersecurity professional, or are you working in tech? Let us know, PC Aviator. Let us know. Okay, is your progress recorded for this platform? Yeah, they do. They keep track of all the challenges that you finished, and I think I finished like 200 or so challenges on the CTF platform. This one, anyways. Let's see. Can we show? Yeah, I'm not too sure if there's an easy way to look at my solved challenges. Just for my SANS certs back in the day. But how many did you truly enjoy? I mean, I enjoyed a lot of the challenges from Pico CTF. It's a pretty good platform. SANS certs. I mean, SANS, you must have... So SANS certs are... SANS certifications and courses. Very good training from what I've heard, I don't know personally because I've never taken SANS training. So from what I've heard, SANS certificates and courses, very good training, very, very expensive. Which means that you probably want your boss to pay for SANS training. Okay, yes and yes. Okay. The military paid for them. Oh, okay. That makes, I mean, sure. Let the military pay for the SANS training. Sounds good. But PC Aviator, do you work in a technical field? What kind of stuff do you do? Curious. We're just talking about the basics of Linux, because I've got a program for teaching people how to do the basics of cybersecurity stuff. Okay, let's do a little review, and we'll wrap up. So let's review the Linux commands we learned in today's workshop. The find command. The find command is used to search for files in the system. It can be used with many different arguments and flags to refine the search parameters. The whoami command is used to return the name of the user account currently being used. Typically, the whoami command is used by people who are doing CTF exercises and malicious actors. So some systems flag the whoami command as a sign of malicious activity. Okay, I'm a retired just overall cyber nerd. I'm not a not a true arch, by the way, just an omarchy. I'm not too sure what omarchy is. But yeah, the rm command. It's used to delete files and directories, but deleting directories requires the use of the -r flag. So keep in mind that on Linux systems, once you delete something from the terminal, you're not getting it back, so be careful when you use the rm command. Oh, it's not arch. Omarchy. Omarchy. Okay. We also use the grep command. So the grep command searches within the contents of files for specified strings. It is very commonly used to pick out specific words or phrases. So grep is used quite commonly when you use Linux a lot, so please learn to use it. What's next? So we're going to keep on using the PicoCTF platform to learn about Linux stuff. And let me take a quick look at this type of stuff we're learning for the next session. Just a second, everybody. Okay, so for session 3, we're learning about, netcat. We're learning about netcat. We're learning more about piping. We're going to learn about the base64 command and recursive stuff. Okay, all right. So it's going to be a fun time, and we're going to be doing it next week. So next week on Wednesday. Okay, PC Aviator says, I love Omarchy. It's just geeky enough for me without... I getcha. Alright, so let's move into the next... the last part. Okay, we're going to be doing some stuff that I don't know very much about. It's going to be a little challenge. So this is topic number 4. We're going to spend a couple of hours doing this, and we'll see where we are after the end of 2 hours. I was going to try Arch soon. I mean, if you're... I wouldn't use Arch as... Okay, so the last... Sorry, we forgot to solve the challenge. So to solve the challenge, we need to bring up the challenge again and submit the flag. Down here, submit the flag. And we're done. Okay, so the next thing we're going to be doing is we're going to be learning about database systems. So this is not exactly beginner-friendly content, but feel free to stick around if you want to learn about non-relational databases. Get the flag, enter the flag, send the flag, bask in glorious victory. Yeah. Oh, you know what? We've got a flag emote on Twitch. So the Shy31 flag. You can use that one if you like. I think this one might be restricted to subscribers, not completely sure. Okay, so we'll talk about what these NoSQL databases are, and then we'll get into solving some challenges. Okay, NoSQL Injection is a vulnerability where an attacker is able to interfere with the queries that an application makes to a NoSQL database. NoSQL Injection may enable an attacker to bypass authentication or protection mechanisms, extract or edit data, cause a denial of service, or execute code on the server. So if you want to take a look at what we're learning right now, you can see it over. There is NoSQL. Not in this case. The link is up in the top in the chat. So NoSQL databases store and retrieve data in a format other than traditional SQL relational tables. So they use a wide range of query languages instead of a universal language like SQL, and have fewer relational constraints. So here we've got an example of somebody doing a NoSQL injection attack. So password is NE wrong password. So the password is not equal to wrong password. And in this case, it comes back and logs the person in. Okay, Aviator says, gotta run, but thanks for taking your time to train others. We need more like you. Thank you. Thank you very much. And hope to see you again, PC Aviator. Okay, I'm going to log into the website because I'm not logged in. Oh. Do they have my information? Okay. Good. Don't need to look up my password. Okay, for more information about NoSQL databases and how they differ from SQL databases, see NoSQL databases. There's some information here. You know what? We should probably refresh our memory on what NoSQL databases are and how they're different from typical web application databases. So NoSQL databases store and retrieve data in a format other than traditional SQL relational tables. They're designed to handle large volumes of unstructured or semi-structured data. As such, they typically have few relational constraints and consistency checks than SQL, and claim significant benefits in terms of scalability, flexibility, and performance. Like SQL databases, users interact with data in NoSQL databases using queries that are passed by the application to the database. However, different NoSQL databases use a wide range of query languages instead of a universal standard like SQL or structured query language. This may be a custom query language or a common language like XML or JSON. NoSQL database models. So there's a wide variety of NoSQL databases. In order to detect vulnerabilities in a NoSQL database, it helps to understand the model framework and language. Some common types of NoSQL databases include document stores. These store data in flexible, semi-structured documents. They typically use formats such as JSON, BSON, I've never heard of BSON, okay, and XML. They are queried in an API or query language. Examples include MongoDB and Couchbase. So, as far as I know, the most common NoSQL database type is Mongo database. I've seen it a lot in different CTF challenges. Couchbase, I think I've seen it once. Key value stores. So these store data in a key value format. Each data field is associated with a unique key string. Values are retrieved based on the unique key. Examples include Redis and Amazon DynamoDB. Okay, SysOS says SQLite and Redis would also be candidates. SQLite is NoSQL? I thought SQLite was just a... SQLite is NoSQL, really? Oh, today I learned. Wide column stores. So these organize related data into flexible column families rather than traditional rows. Examples include Apache Cassandra and Apache HBase. Graph databases. These use nodes to store data entries and edges to store a relationship between entries. Examples include Neo4j is a NoSQL database. Neo4j is associated with Bloodhound, which is a very popular tool for doing Windows security testing. Amazon Neptune. Okay. SQLite isn't. It's not typical SQL. It isn't NoSQL, and Redis is a caching server, not a database. Okay, let's. All right, so that's all they have for node database information. Let's get into how to hack these things. The stuff we're really interested in. Okay, types of NoSQL injection. So there are two types of NoSQL injection. Syntax injection, and this occurs when you break into a NoSQL query syntax, enabling you to inject your own payload. The methodology is similar to that used in SQL injection. However, the nature of the attack varies significantly, as NoSQL databases use a range of query languages and types of query syntax in different data structures. Operator injection. So this occurs when you can use NoSQL query operators to manipulate queries. So in this topic, we'll look at how to test for NoSQL vulnerabilities in general, then focus on exploiting vulnerabilities in MongoDB, which is the most popular NoSQL database. Okay, so that's confirmed. Great. We've also provided some labs so you can practice what you've learned. NoSQL syntax injection. Less functionalities? Heck shoo. I'm not. What is less functionalities? You can potentially detect NoSQL injection vulnerabilities by attempting to break the query syntax. To do this, systematically test each input by submitting fuzz strings and special characters that trigger a database error or some other detectable behavior if they're not adequately sanitized or filtered by the application. If you know the API language of the target database, use special characters and fuzz strings that are relevant to that language. Otherwise, use a variety of fuzz strings to target multiple API languages. Detecting syntax injection in MongoDB. Consider a shopping application that displays products in different categories. When the user selects the fizzy drinks category, their browser requests the following URL. Okay, so insecure website, product lookup, category equals fizzy. This causes the application to send a JSON query to retrieve relevant products from the product collection in the MongoDB database. So this category is fizzy. This category is fizzy. To test whether the inputs may be vulnerable, submit a fuzz string in the value of the category parameter. So an example string in MongoDB is... What's happening here? Foo, and then just a bunch of... So use this fuzz string to construct the following attack. Okay, we've got a bunch of URL encoded characters that include foo. If this causes a change from the original response, this may indicate the user input isn't filtered or sanitized correctly. NoSQL injection vulnerabilities can occur in a variety of contexts, and you need to adapt your fuzz strings accordingly. Otherwise, you may simply trigger validation errors that mean the application never executes your query. In this example, we're injecting the fuzz string via the URL, so the string is URL encoded. In some applications, you may need to inject your payload via a JSON property instead. In this case, the payload would become... okay. So... stuff between brackets, and then look for the foo variable, and then U0000, is that like the new line? Determining which characters are processed. To determine which characters are interpreted as syntax by the application, you can inject individual characters. For example, you could submit single quote, which results in the following DB query. So this category is something. If this causes a change from the original response, this may indicate that the single quote character has broken the query syntax and has caused a syntax error. You can confirm this by submitting a valid query string in the input, for example by escaping the quote. If this doesn't cause a syntax error, that may mean that the application is vulnerable. If this doesn't cause a syntax error, it may mean that the application is vulnerable to an injection attack. Okay, so after detecting a vulnerability, the next step is to determine whether you can influence Boolean conditions using NoSQL syntax. So to test this, send two requests, one with the false condition and one with a true condition. For example, you could use the condition statements and 0 and x and 1 and x as follows. Okay, so just inject that stuff. So this has all been URL encoded. So the ampersands become %26. If the application behaves differently, this suggests that the false condition impacts the query logic, but the true condition doesn't. This indicates that injecting this style of syntax impacts a server-side query. Overriding existing conditions. Now that you've identified that you can influence Boolean conditions, you can attempt to override existing conditions to exploit the vulnerability. For example, you can inject a JavaScript condition that always evaluates to true, such as or 1 equals 1, or 1 equals 1. Oh, this seems very similar to our SQL injection payloads. This results in the following MongoDB query. So this category is fuzzy or 1 equals 1. So as the injected condition is always true, the modified query returns all items. This enables you to view all products in any category, including hidden or unknown categories. Warning: take care when injecting a condition that always evaluates to true in a NoSQL query. Although this may be harmless in the initial context you're injecting to, it is common for applications to use data from a single request in multiple different queries. If an application uses it when updating or deleting data, for example, this can result in accidental data loss. So this is kind of the same thing they talk about when they talk about your classic SQL payloads. Classic SQL login bypass payload. So in this case, you'd run something like or 1 equals 1 dash dash dash. So something or true. So it would typically be like something like username equals blank or 1 equals 1, quote out everything else. And this is what they take issue with. So if you inject or 1 equals 1, which is true, sometimes this will affect the application in a way where it deletes data. And this is what they're trying to warn us about. But of course, we're not talking about SQL, we're talking about NoSQL. Okay, so detecting NoSQL injection. Let's solve this lab. Okay, so the product category filter for this lab is powered by a MongoDB NoSQL database. It is vulnerable to NoSQL injection. To solve the lab, perform a NoSQL injection attack that causes the application to display unreleased products. Okay, so I'm just going to be recording how we solve each one of these challenges because I need to build up a little collection of how to hack NoSQL. So I'm going to do that over here. So this is for Pico CTF? No, Portswigger. NoSQL injection. And this challenge, well, we'll just number these challenges as well. So detecting NoSQL injection .md. We'll record a few different things for each one of these challenges, the URL where you can find the challenge, the concept we need to understand to do the challenge, and the method of solving the challenge. So in this case, this is detecting NoSQL injection vulnerability. I guess we can also just call it testing it. Testing NoSQL injection vulnerability. Okay, let's get into it. So we'll access the lab. And we'll try doing what they suggested in the previous section. So payloads that look like this. Most of the time when you're doing these kind of labs, they usually cover the exact way you solve the lab in the education section beforehand. Okay, here we go. So the first thing we need to do is select a category. So we're looking for food and drink. And this is what we get back. So the thing we need to pay attention to is the URL parameter here. So category. Category equals food and drink. And what we need to do... okay. So the ampersand here has been URL encoded into the %26. So this should have been food and drink, like this. Okay, so what we need to do is we need to try injecting into this. So I guess we would try to put in like a single quote. So we can put a single quote here and see if it affects the query in any way. Okay, so we get an error. So internal server error. This gives us a lot of information. So I'm not too sure. Is this called a stack trace, or is this just called like a general like error message? So the error message is this. So JS interpreter failure, syntax error. So this is a JavaScript application, okay. Probably like Node.js. So this is where we would spot that this is a MongoDB NoSQL database that's being used. And so we're able to get an error message. The first step is to inject some sort of single quote or double quote to get an error message, and that confirms that we're able to interfere with the database query. I guess we can record this as well. In the app, we can select the category to filter for. In the resulting web page, we see this URL parameter. So category equals food and drink. We can try to inject a single quote. Into the query, into the parameter, to see if we can elicit a change in behavior. So it would be category single quote food and drink. So this causes an error. So this causes an error which looks like this. So this is also kind of similar to what you would do as a pen tester. When you're writing up your report, vulnerability. Okay. You have to do a lot of you have to do a lot of documentation when you work as a pen tester. Okay, so this indicates that the web app is using a MongoDB. I mean, indicate is a strong word. Maybe it's this points to the possibility MongoDB NoSQL database. Yeah, LLMs and standard document snippets can help. You're usually including a lot of like little code snippets, commands, and stuff like that. You need to tell your client how you got in so that they can recreate the vulnerability on their end. If they're not able to do it, then it really calls into question whether or not the vulnerability exists. Okay, so from here we try some MongoDB NoSQL injection payloads to determine if we can output additional information. From the database. All right, so back. So what kind of payloads were they talking about? So they're looking for something like this one right here. So or 1 equals 1. So this category equals fuzzy or 1 equals 1. We also need to URL encode this. Well, we might not need to URL encode this. Sometimes we might have to. So we'll just copy the payload directly. And then we'll go up here. And we'll just paste this onto the end. And that solved the lab. Okay. So food and drink, or 1 equals 1. So or true. So let's see what some of the extra stuff here was. I don't even know what we might be looking for here. But anyways, we solved the challenge. Alright, so before we go, I guess we'll record this. So this payload will output all of the products from the database. Commit changes. Okay, so it's, well, I mean, this one was pretty easy, but they're probably going to get more complicated from here. The word selection. The words selection. Wait, did I select some weird words? Oh, was that one of the products? Okay, let's, so we completed this one, and we'll move on. Okay, so next, so you can also add a null character after the category value. MongoDB may ignore all characters after a null character. So this means that any additional conditions on the query are ignored. For example, the query may have an additional this.released restriction. So this.category equals fizzy and this.released equals 1. So the restriction this.released equals 1 is used to show products that are released. For unreleased products, presumably this.released equals 0. Oh, I meant when you change this points to the possibility. Oh, did I not write that out correctly? This points to the possibility that the web app is using a MongoDB NoSQL database. I mean, the error message by itself doesn't confirm explicitly that it's using MongoDB, but the word Mongo here and the fact that it's and the fact that this is like a Node.js application kind of points to that fact. Mongo helpers, yeah. All right. Just awesome. Well, it's a bit ambiguous. You gotta cover your butt when you can. Okay, so what's the next challenge? So in this case, an attacker could construct an attack that as follows. So insecure website, category equals fizzy, and null byte. So this category equals fizzy, null byte, and this release equals 1. So this is an example of quoting out, which you'd normally do in a regular SQL system with like a double dash. Ignores all characters after a null character. This removes the requirement for released set to something. Okay. NoSQL operator injection. So NoSQL databases often use query operators, which provide ways to specify conditions that data must meet to be included in the query itself. Examples of MongoDB query operators include where, matches documents that satisfy a JavaScript expression. NE matches all values that are not equal to a specific value. In matches all values specified in an array. Or regex selects documents where values match a specified regular expression. You may be able to inject query parameters, query operators, to manipulate NoSQL queries. To do this, systematically submit different operators into a range of user inputs, then review the responses for error messages and other changes. I think So as far as NoSQL injection is concerned, Pfizer, hello, nice to see you here. If I keep watching your channel, can I become a hacker like Pierogi, who undermines the scam artists in other countries? I don't know about this particular person, but do they have like a YouTube channel? Pierogi? Let me look him up. Eamon says, I'm back. Are there any websites that you recommend to learn pwn and pivoting? Pwn and pivoting. Oh, Scammer Payback. You're talking about Scammer Payback, right? I know Scammer Payback. I didn't know that the guy's name was Pierogi. But Eamon, yeah, you're talking about free websites to learn pwn and pivoting? Yeah, I mean I've got my education resources over here. Let me point you towards them. I mean, my go-to answer about learning about binary exploitation is Pwn College. I don't cover Pwn College because they don't let people cover their solutions for their stuff, but it's the best. And you'll find it in here. So Pwn College, program security, return-oriented programming. There's a lot of stuff here. But Pfizer, yeah, Scammer Payback, if I keep watching your channel, can I become a hacker? Well, I mean, it really depends on what kind of hacking you want to do. If you want to do the exact hacking that Scammer Payback is doing, he's probably doing some sort of like web app hacking stuff. Are you Canadian? You are Canadian. Oh, that was you are Canadian. Yeah, I am Canadian. Yeah. I am located on the West Coast. But yeah, Pfizer, check out the tiny URL link. It leads to a Reddit thread on our subreddit that talks about getting into cybersecurity. There's a bunch of resources there. Hopefully it can point you in the correct direction. Okay, so let's keep on learning about NoSQL. So NoSQL, as far as NoSQL like injection is concerned, I'm pretty sure there's a list of common NoSQL injection payloads. And Camel, hello, nice to see you here. Tu parles français? No. I live on the west coast of Canada. Not a lot of people speak French in the West. But, I mean, je ne parle pas français. I learned it for about 3 years in high school, and high school was a long time ago. Do you speak French, Hekshu? If you do, I've got a website for you. HackerPoll. HackerPoll.fr. It's a French cybersecurity education website. More than 2 years ago? Yeah, more than 2 years ago. What was I doing? Yeah, I was talking about common NoSQL injection payloads. So I'm pretty sure I can search for it, like find, or like locate is better probably. Locate seclists grep for NoSQL. Grep insensitive NoSQL. No, well, I'm pretty sure it's out there and like payload all the things. Let me look really quick. Or even like payload playground. NoSQL injection. Here we go. That's like such a long time ago. Yeah, sure. Okay, so we can select the database type MongoDB and the injection operator injection. So for example, if we want to do injection as the admin user, we could use it like a payload like this. Let me see if I can find some other NoSQL injection payloads on like payload all the things. So it's this is a GitHub repository with a bunch of payload all the things. Web application security, pentest, and red team cheat sheet. Okay. Can we search for NoSQL in here? Here it is. Okay. If anybody's interested in taking a look, it seems like there's a lot of good stuff here. But anyways, back to Portswigger. So you may be able to inject query operators to manipulate NoSQL queries. To do this, systematically submit different operators into a range of user inputs, then review the responses for error messages and other changes. In JSON messages, you can insert query operators as nested objects. For example, username wiener becomes username not invalid. So instead of submitting your username, you submit not equal to something. So not equal to something, so it's basically looking for like username true in this case. For URL-based inputs, you can insert query operators via URL parameters. Username wiener becomes username any invalid, not equal to invalid. This is pretty similar to what we saw on Hacker Holidays. And Hacker Holidays, the NoSQL stuff there, is what got me interested in doing this particular segment. So if this doesn't work, you can try the following. Convert the request method from get to post, change the content type header to application JSON, add JSON to the message body, inject query operators in the JSON. You can use the content type converter, okay? Detecting operator injection in MongoDB. Consider a vulnerable application that accepts a username and a password in the body of a post request. Username wiener, password Peter. Test each input with a range of operators. You can test whether the username input processes the query operator. You can choose the following injection. Username not equals true. Not equals invalid in this case. Password equals Peter. So if the $any operator is applied, this queries all users where the username is not equal to invalid. If both the username and password inputs process the operator, it may be possible to bypass authentication using the following payload. So username any invalid and password any invalid. Okay, this query returns all login credentials where both the username and password are not equal to invalid. As a result, you're logged into the application as the first user in the collection. So to target an account, you can construct a payload that includes a known username or a username that you've guessed. For example, username in admin, administrator, superadmin. Oh, this is interesting. So you can actually search, you can try to log in as any one of these users. So admin, administrator, or superadmin using this operator here. And password is not equal. Not equal to nothing in this case. Okay? All right, let's just try the lab. So here's the link if you want to try this out yourself. You'll need an account over at Portswigger if you want to do the lab. But I highly recommend making an account for Portswigger if you're interested in learning about web app security, because these are really good labs. They're also completely free. You don't have to pay for any of them. Okay, I'm just going to start my documentation over here. Okay, so we'll record a few different things for this challenge, the URL where you can find the challenge, the concept behind the challenge, and the method of solving the challenge. So for this lab, it's over here. This concept for this challenge is actually, I guess like MongoDB, NoSQL login bypass. And let's get into it. The login functionality for this lab is powered by a MongoDB NoSQL database. It is vulnerable to NoSQL injection using MongoDB operators. To solve the lab, log into the application as the administrator user. You can log into your own account using the following credentials: Wiener Peter. Okay, so we're being told specifically which user to log in as. This is good. Okay, access the lab. Okay, so we'll try logging in first as our own user. And you know what? This is a good opportunity to use Burp Suite. So because the Portswigger Academy is created by Portswigger, and Portswigger is the maker of Burp Suite, which is the most common tool used in web app security testing, it's probably going to benefit us to use Burp Suite to do these challenges. Okay, we'll bring up the proxy tab, and from the proxy tab we can open up the Burp Suite browser. So we're just gonna send a few login requests via Burp or the Burp Suite browser, and in this way we're going to be able to log all that information. Okay, sorry about the flashbang. The Burp Suite browser doesn't have dark mode. Okay, Wiener Peter. This is our user. Okay, now we're logged in. Alright, so after we've done this, our login request would have been recorded by the Burp Suite proxy over here in HTTP history. So we click on login, and we can start messing around with this parameter, with this login request over here in the repeater. And our information was being sent as a JSON object. So the JSON object looks like this. So username Wiener, username Wiener, password Peter. So in this case, we want to log in as the administrator. And our password, we're going to pass in as some operator. So the most as far as I know, the most common login bypass is the one that we saw over at Payload Playground, right? So for NoSQL, I like Payload Playground, except for the fact that it's a heavy website, which means that everything loads in really clunkily. So in this case, we're trying to log in as administrator. And we're going to use the operator injection not equals. Username not equals administrator. I mean, that's not what we're trying to do. I think we're trying to do this. So password not equal to Peter. Like this, maybe? We'll try this out. If it doesn't work, then we can try some other payloads. So it doesn't matter what the actual value we're passing via the password is here. We just need to make sure that it's not a valid password. In this case, Peter's probably not the correct password for administrator. Then what we're trying to do is we're trying to pass a query. Shouldn't it be not equal to void? I mean, maybe. Depends on how the system is set up specifically. So sometimes we need to provide like a invalid string. Sometimes we need to provide like a null value. I'm not exactly sure. But we'll try this out. If it doesn't work, we'll try some other stuff. Okay, so we'll just delete what we have here, paste in the new thing. It doesn't look very nice. Send it. Bad request, invalid JSON. Okay, so this is not a valid JSON object. So what did they say about embedding stuff into JSON objects? Let's take another look. So username something. Okay. So here we're just injecting into the value. So NE invalid. Okay, password normal. The value is another JSON thing. NE bar. Password NE bar. Maybe. But we'll try this. We'll see if it's valid JSON or not. Okay. Send it out. It came back okay. All right. So we'll request this in the browser in original session. Copy this. Invalid username or password. Okay, so this didn't come back okay. Let's go back. So we can also render the result. Invalid username or password. So this didn't work. This is also a very handy part of Burp Suite. So we can send the requests with all the information here. We can get what would be rendered by the web browser by clicking on render in the response. Okay, so what were some other possibilities? So HackerFrogs, let's try your suggestion. So $NE equals bar. That's kind of the same thing. Why do you want to restrain it to administrator? You lost me there. Why do you want to restrain it to administrator? Well, I mean that's what they told us in the challenge description. So in the challenge description here, they say to solve the lab, log into the application as the administrator user. Other username? No, I mean they tell us specifically log in as the administrator user. Okay, so we could also try this. Bad request. This is invalid JSON. No worries, no worries. Test each input for a range of operators. So any invalid. So username. I think we're specifically targeting the password here. So we could also try this. So password is this object with like, you know, blank. Thank you very much, Zabriel Carpio, for subscribing on YouTube. Thank you. Much appreciated. Okay, did we actually log in? Invalid username or password. Okay. Let's take a look at the payload playground. So we're URL encoding, target parameter field name. It's not username, it's password. Payload value administrator. I mean, this is just going to be like a test, right? So operator injector not equals, where function, let me check out the one that we did for the other hacking challenge. So the one that we used for hacking holidays. Take a quick look at that thing. Let's try hack me. I think it was like day 8? No, day 7. It was day 7. This is why we need to keep notes. Yeah, no SQL login bypass. So password NE equals 1. But this isn't specifically for JSON though. Password NE equals X. Yeah, that's the one we used for, but because this is JSON we're passing in, it might not work. Maybe we can put in 1 as our, here we'll do another JSON object. Called like password. Or like just NE equals 1. Bad request. So this is invalid JSON. Let's take a look at payload all the things. Found this. Username in admin password GT. I mean, I wonder if it is GT. in this case, like greater than something something, right? Tools, automated NoSQL database enumeration exploitation tool, a lab for playing with NoSQL injection. There's a burp NoSQLi scanner for Burp Suite as well, and that's good. Username, password not equal null. So I guess this is where we inject I think we've done this already though. Hold on, let's try it again. So this is like password, this thing. Invalid username or password, okay. So putting in null. What other payloads do we have? Any foo, password, any bar. regex JSON data for regex. Password greater than. Well, we could also try the greater than, sure. Okay, let's try a bunch of different ones. Okay, so greater than. This didn't get us in. So greater than, we tried regex. Send that. Still invalid. So we tried regex, we tried greater than. We tried undefined. So it's still greater than for this one. Case sensitive for the user, I mean. They told us about which user. Administrator. It has to be, in this case it would be lowercase. Bad request. Invalid JSON. Let's try a few more. So regex JavaScript injection where string or where function. So we tried any, we tried greater than, we tried regex. But it's usually simpler than this. The exact payload is usually in the learning material here. So in this case, we provide not equal to empty string. We'll try this. Any invalid something something. Submitting query operators. What's the reason why you use Wiener Peter through burp? What's the response when you try Wiener Peter through burp? So the Wiener Peter request, the valid one, we'll take a look back at the proxy. Is 302 found. So when we see 302 found, we'll know that we've got a match. So we're looking for HTTP response code 302. So username Wiener, password Peter, NE invalid. So we might also need to use, we might want to try this one as well. Sure, why not? I'm not too sure how it works, but we'll give it a try. So username is this other thing. And password is this thing. Okay, invalid. I mean, we can also just delete all the other users, aside from the user we're actually looking for, which is the administrator. When you post an invalid user, the page loads, but it doesn't load a 302. Yeah, I mean, it responds, but it responds with 200. Without, and not a 302. So 302 is like a redirection, and it's usually going to redirect you to an authenticated page. If both the username and password inputs to the processes the operator, it may be possible to bypass authentication following payload. So we'll just try using the full bypass payload here. And see if this works. Bad request, so they don't consider this proper JSON. Oh, but I actually sent an extra internal server error. Okay, so this didn't work. Query returned unexpected number of records. Oh, interesting. Unexpected number of records. So this actually returned everything. But we don't want to return everything. We want to return one thing. Okay, so the username is administrator. but this doesn't come back okay. Wouldn't admin pass be in everything? Hello, Randolph. Hey, what's going on, man? We're just trying to learn about NoSQL injection over here. Let me just look for... Just search for something, right? NoSQL login bypass payload. Maybe there's like a collection of them sitting around somewhere. NoSQL injection cheat sheet. Okay. Probably dump all the creds with the union. I've never done... Well, I mean, I don't have very much experience with NoSQL in general, so this is why we're doing some of this stuff. SQL injection cheat sheet. We're looking for specifically... So any equals null or GT equals empty string. So vanilla authentication bypass. We'll give this a try. Yeah, okay. And the other one was any equals null. I mean, we've tried this a bunch of times, but... Okay, blind techniques, code potential, code injection potential. Test to check if a NoSQL injection is possible, syntax breaking tests. URL encoded form parameters. I mean, not in this case. In this case, we're using JSON requests. So param regex. We could try the regex one again. Yeah, but this came back as invalid. Boolean condition tests. MongoDB. So operator injection authentication bypass. We've tried this one. We've tried the greater than. Using in array membership. So username. Oh, you know what? We haven't tried this one specifically. Okay. So we'll just use this instead of username. Invalid JSON. Hold on. Let me look. So we'll do this as the whole thing. Bad request. $200 OK. 200 OK, but it says invalid username or password. Using exists in NIN for reconnaissance. Data extraction with regex. Testing field length. Extracting field character by character. Okay, so I mean this is more like blind SQL, like blind injection or like time-based stuff. The where operator evaluates a JavaScript expression against every document in a collection. Basic authentication bypass, where 1 equals 1, where this user equals admin. where 1 equals 1. This looks suspiciously like regular SQL injection bypass. I mean, we'd have to use like username administrator for this one. And what would that be? Password. Where 1 equals 1. Internal server error. Okay. So this made the application error out. Okay, we'll give this another 15 minutes or so. And if we can't get this in 15 minutes, we'll spoil ourselves and so we can move on to the next thing. So where this password, this username equals admin. Where this username equals admin, I guess administrator. This is how you spell the word administrator, right? Administrator. So this errors out the application. Given that you got the password bypass to work when you dumped all rows, I think the issue is the username, so challenge description is wrong. Challenge description is wrong. I mean, people would complain pretty quickly if the challenge description was wrong. Well, we can just try admin. Actually, wait. Let's try like a user we know, because we know that there's Wiener. Okay, so we'll just get the full bypass first. And we'll just try that. We'll see that it errors out because of like too many rows returning, right? No, that's not valid JSON. Yeah, query returned unexpected number of records. So we're just gonna do username equals Wiener. And password is any invalid. 302 found. So this works. So is the challenge description actually wrong? So invalid username or password, admin, administrator, so it looks like root, Carlos. We found Carlos. Hold on. Maybe the... Wow. Is it... I'd remove that weird stuff for the password and just go for the any that you know worked. I mean, the any that we know worked. But the administrator user doesn't exist. Hold on. Let me copy paste it directly. Log into the application as the administrator user. Specifically. Right? send that. Invalid username or password. Wait, maybe it's capitalized. No, it's not capitalized. Administrator with an R with an 8. Yeah. So we know it works. So if we use like a user we know, this is account found. And you know what? Let's just try logging in as Carlos. Yeah, so this works. We'll get this in the browser in original session. Because typically in these challenges, you have to log in as Carlos. Yeah, we're not finished. It would say that we're solved. Maybe that's not the literal username, but rather the account for the administrator. Strange. What other usernames could it be? Like root regex to test a bunch of variants? Maybe. The thing is that why would they lie? Why would they lie in the lab description? Log into the application as the administrator user. Can you void just for user? I mean, we could do this, right? The full bypass is to test whether the username input processes the query operator. Yeah. Reasoning regex admin. Password. Yeah, I mean, we could try. Something admin, right? Let's give it a try, Hekshu. What's the worst that could happen? Invalid JSON. Okay, let's remove this. And this is also going to be invalid JSON. Oh wow, this worked. Whoa, why? Why would you do this to us? So it was a random name for the administrator. That's sneaky. Could have just been miscommunication if admin wasn't fixed with flaunt. Yeah, okay. But Hekshu, yeah, that worked. This is infuriating. Alright, so request in browser in original session. So it turns out it was administrator plus a bunch of like random letters. It only took an hour. Well, you know what? The important part is that we finished it, and yeah, it's kind of unfortunate that the lab lied to us. And that the administrator, that the exact like name is not the same. I guess we were supposed to infer. Anyways, thanks Hekshu. All right, let's do the write-up for this. Plus, you learn more at NoSQL than you would have otherwise. True. because I was just ready to put in the regular payload and call it a day. Okay, so the method is solved. So this we log in as our regular user with the credentials. Wiener Peter. Okay, we record the login with the Burp Suite browser. Then throw the post request to the repeater. This was an interesting one. Well, interesting is one way to put it, I suppose, yeah. Okay, so we put the post request in the Burp Suite repeater, and the JSON we send looks like this. It actually doesn't look like this. It looks like username Wiener, password Peter. And this was a command redacted by the NRA. Okay. So we need to inject our payload into the JSON object. We find that if we use this payload, it logs us in. As Wiener. The guys at Burp are liars. I guess we could say that. I wonder how much crap they got from the users who found out that they needed to do the regex stuff. So it's just like something like this. Actually, let's get the exact payload. I don't want to be inaccurate here. So any something something invalid, right? So this app is vulnerable, and if we send this payload, it errors out and says it tried to retrieve too many rows. So this is the double. So username and password is both any invalid or whatever. The problem is that all of our attempts to log in as admin or administrator fail. So there's something else afoot. The solution is that the username is admin, but with random letters. appended to it. For example, admin x like this. The actual payload that gets us in has regex elements in the username field. Okay, and let's get the actual payload. Alright, finished. Alright, so the important part is that we're able to move on after this. Okay, let's take a look at what the next section is. Exploiting syntax injection to extract data. So in many NoSQL databases, some query operators or functions can run limited JavaScript code, such as MongoDB's where operator and MapReduce function. This means that if a vulnerable application uses these operators or functions, the database may evaluate the JavaScript as part of its query. You may therefore be able to use JavaScript functions to extract data from the database. Extracting data in MongoDB. Consider a vulnerable application that allows users to look up other registered usernames and displays their role. This triggers a request to the URL, lookup username equals admin. This results, okay, so this is going to be something similar to union injection in regular SQL. This results in the following NoSQL query of the user's collection, where this username equals admin. As the query uses the where operator, you can attempt to inject JavaScript functions into this query so that it returns sensitive data. For example, you can send the following payload: admin and this password, admin and this password equals A or A equals B. So this password element 0? Oh, okay. So we're doing a Boolean test. So the first element of the password array is A. So we're testing for the letter A in the first letter of the password. Or false. True or false. So if it comes back both false, okay. Okay, I think I understand. So this returns the first character of the user's password string, enabling you to extract the password character by character. You can also use the JavaScript match function to extract information. For example, the following payload enables you to identify whether the password contains digits. This password match digits or A equals B. Okay, so this is a more complicated one. Yeah, the interesting thing about this one is, I think, unless this lab has a very, very short password we're supposed to extract, we'd probably want to use some sort of tool to do this, because otherwise, doing this kind of Boolean SQL injection is really, really time-consuming and very, very tedious. But hey, we're here to learn. Okay, so this is going to be lab number 3. The interesting thing is that all the stuff that we're doing in here they all have parallels in regular SQL injection. It's just that we're dealing more with JSON and like JavaScript instead of SQL language. Repeater and burp. I mean, we would also do repeater and burp for regular SQL injection testing. If we're doing it manually, of course. A lot of the times when we find SQL injection, unless it's like just one query that we're going to send, and that's almost never the case, we usually pass it off to some tool. Control R? Oh, there's a keyboard shortcut? Yeah, I never use the keyboard shortcuts in burp. Okay, so here's the lab. The concept is NoSQL injection to leak database contents. Okay, let's start the lab. The user lookup functionality for this lab is powered by a MongoDB NoSQL database. It is vulnerable to NoSQL injection. To solve the lab, extract the password for the administrator user. Are you sure it's the administrator user? Or is it going to be some random administrator name? Then log into their account. You can log into your own account using the following credentials. Wiener Peter. Tip. Please give me a tip. The password only uses lowercase letters. Only uses lowercase letters. Thank you for letting me know about that. That's going to save me a lot of time. Okay. Access the lab. Alright, so we'll put it in Burp Suite, like we did before. And then... oh yeah, burp that baby! Hey, Xmetric! How are you doing? Okay, we'll log in as our typical user, Wiener Peter. Okay, so from here we can start doing our malicious NoSQL injection. So the post request is over here. Actually, no. They said that it was doing okay. Great to hear. Great to hear. Thank you very much for following on Twitch, Chen Feng Numbers. Thank you. Okay, so there's the user lookup functionality. So where's the user lookup function? Is it down here? Is it up here? Where is the user lookup function? Xmetric says, I always wonder why people pick the numbers in their names, like that guy 124. Could it chose that name because that guy 123 was taken? I mean, numbers usually signify something important, so it might be like a date. It might be a date, or it might be some other thing of significance. I mean, who knows, really? Birthday, etc. Yeah, maybe. Wait, maybe we need to log out first. So my account, log out. Those people are the easiest targets. Okay, so my account. Hold on. Let's look at account lookup. There it is. All right, we'll put it in the repeater. Unauthorized. What do you mean by unauthorized? Wait, do we need to be logged in first? Or even when their passwords are almost always in password lists. Oh, really? Well, I mean, I don't know. Unauthorized. We can't use this one. Lookup user equals wiener. Hold on. Let's log in first. And how do we do the... Do we just like refresh the page? / user lookup. This just comes back okay. Nice. Nice X-metric. Very, very lead. Okay, so we've got... So we're supposed to be injecting to this. So user equals something something, right? User equals wiener. In this case, they told us about the data extraction process, or like the string, the payload. So in this case, it would be admin and this password match something something. Admin and this password. Okay, so what would it look like? So user equals admin and this dot password. I mean, does this come back true, or does this come back as something else entirely? So what if we do just admin? Could not find user. Okay, so it's not admin, it's administrator. Could not administrator. Have to spell correctly, everybody. Spell it right? Yeah. Thanks for letting me know. Okay, so user equals administrator and this password element 0 equals A or A equals B. I mean, if this is the pattern, it's going to be a very tedious task. There was an error getting user details. There was an error getting user details. So do we just start doing B, C, D, E, F, G? Or is it because our stuff is not URL encoded? Or 1 equals 1. I mean, this is the payload they taught us. I'll just try everything up until the letter Z. And if it doesn't work, then I'll try another payload. Or I'll try URL encoding the payload. Doesn't control enter send? Does it? I don't use a lot of Burp Suite shortcuts. Rage. I mean, I guess we could use the intruder, yeah. But the other thing is that I think we need to URL encode this. So end because this is not on the same line. Oh, maybe it was because of like the punctuation. Wait. How did Does RAW not show it URI encoded? Let's show the new lines. So we need a... Okay, let's... Yeah, for some reason it truncates this. It tries to change it. You know, it might be an easier thing to do if we sent this through the web browser. Okay, let's send it through the web browser instead. Uh-oh. I'm not logged in here. That's weird. Hey, thank you very much, Ozusa, for subscribing, and Tier 1 for 9 months. Wow, that's quite the amount of time. Thank you. That's a very dedicated user. Thank you very much, Ozusa. Let's give you some Hack the Planet. Thank you very much for the subscription.
Hack the planet! Hack the planet! Shut up again!
Okay, we'll log in as Wiener Peter. Yeah, much appreciated, Ozusa. HTTP goes on the same line as the URL. It's get URL HTTP. Oh, really? Okay. So that wasn't a... That wasn't an error. Okay. All right. sorry, let's send the get user lookup, right? So this thing. So this isn't something that's usually visible via the web browser. There's an error getting the message details. Okay, so this URL encodes everything. Unfortunately, I can't make the address bar bigger so that it's easier for you guys to see. Otherwise, I totally would. Okay, so I think the first thing we need to do is we need to make sure that we've got a payload that... We need to make sure we have a payload that actually returns something valid. Plus, you don't want the final quote in it. Oh, you don't want the final quote. Okay. A equals A, the condition should be false, just to make the whole query valid. Unauthorized. Oh. Are we not logged in? I need to look. Okay, so this comes back okay. So I guess we need to URL encode all this stuff. I mean, I'm not sure if we do or not, but we probably should. Based on the firewall? Hey, Chen Feng, nice to see ya. That condition should be false just to make the whole query valid. I mean, I want to make it true first, just so that we can return something. Okay, this is not fun to look at. Could not find user. Okay, could not find user. That's better than there is an error getting the whatever. Actually, let's replace this A with the B. And see if it... Ah, okay. All right. So I think we've got a valid method of testing here. We just need to change out this character right here. So this A, we'll change it to a B. Oh, sorry, we need to... We're not really doing testing at this point. We need to replace... So A is equal to B. So this is supposed to be false. So false could not find user, okay. Change it to A. Then to B. So we do it here. So if we actually see the information, that means we've got a correct letter. C D E. I should probably send this to the intruder. But I just want to get one hit first. L M N. I'm sure this is very, very fascinating and very exciting for everybody to watch. Q R S T. Super, yeah. U V W. Ah, the first character is W. We found it. It only took us like 2 minutes. And a lot of tedium. Okay. Alright, so we found the first letter is W. I guess we'll record it somewhere. How about here? Okay, I'm not too sure how many letters this password is, but we know the first letter is W. Okay, so we'll send this to the intruder, and then we'll try doing a brute force attack. So the payload is right here. Okay, and the payload configuration is well, I'll create the payload. So the payload is A, B, okay, so let me get that so that I can copy paste it. Just need to double check to see if I didn't miss any letters, because that would be a sad thing. Okay, we'll paste it into... Okay, so 26 letters. And this time we're changing this password. Where's the 0? Man. So this is actually another... Okay. So this is this password 1. And we're attacking on the letter. We'll start the attack. Yeah, the room is exploiting NoSQL injection to extract data. Yeah, that's the room. I mean, if you want the room, if you want the lab itself, I can give you it. So this one right here. So this gets the... So we find one that is of a different length. So this one was the letter N. So now we know that the second letter is N. So it's WN. So we'll get the third letter. We're just looking for the one that has a different length. Here we go. So O. So O is the next letter. So what we're doing is we're basically going to be testing all these letters until one of the letters doesn't have anything, and then we'll know that that's the password. Wish there was a faster way of doing this, though. There probably is. Okay. So now we're looking for the fourth letter. I'm gonna try to do it all at the same time. Yeah, you can probably do it all at the same time by testing on two areas at once. So the next letter is F. The next letter is F, and then the letter after that. Running a quick Python script would probably have been faster. Probably. You know what? We might go back and do that afterwards. Alright, so what was this one? B? Actually, either the Python script or like setting multiple payloads. The problem with doing multiple payloads with the free version of Burp Suite is that it would slow down immensely after like the 20th request. So it's actually starting to slow down now. Okay, so 209. This is X, so the next letter is X. Yeah, so probably doing it through Python is the better way to do it. Okay, so this was nice and fast. So this one's B. I'm hoping it's not longer than 8 characters. So what we're looking for here is we're looking for an eventual attack where all 26 of the letters comes back negative. So that's the letter Z. And that would indicate that we've got the full password. Okay, we'll spend another 40 minutes doing this, and then we're gonna have to call the stream. I haven't done brute force attacking like this in a while. So did we record that? Yeah, okay. So the next one is the 9th character. Come on, everything come back. Negative, please. Awesome, awesome. I think we've got the actual password now. Okay. So we'll just copy this. We'll try to log in as the administrator. If it works, then we've solved the lab. Okay, so my account, login, administrator. Done! Great! We solved the lab. Yeah, we'll go in and we'll try creating the Python script that automates this, because this is not very fun. Doing it in Burp Suite wasn't very fun. I guess we can get the... Yeah, okay. Let's do the write-up. Then we'll write the Python script and we'll try it out. So the method is solve. So this lab requires us to exploit the slash user lookup endpoint. Exploit the user lookup endpoint to extract the password for the administrator user using NoSQL injection. Log in to the app using our usual credentials. Wiener Peter. Then reload the page. In Burp Suite HTTP history, we should see a request to the user lookup endpoint with the parameter user equals wiener. Send that request to the repeater. And inject a... What kind of payload would we call this? NoSQL injection payload. NoSQL payload to retrieve, to do a Boolean search as to whether the administrator user's password first letter is the letter A. Okay, so we'll highlight the payload here. And this is it's a doozy of a payload. The payload actually looks like this. And we'll give the URL decoded version of it over here. URL decode. We value your privacy. Why are you bothering me? Okay, so this is the much easier to look at version of the payload. So what do we say about this? We can send this payload, or send this request to the burp suite intruder to do a brute force attack. Every time the request comes back with a larger response size. Comrade Soul, hello, nice to see you here. Whose emotes are those, by the way? Reika. I don't know this channel. Could you link me the channel, Comrade Soul? What kind of streams does Reika do? So every time the request comes back with a larger response size, we know that letter is the correct letter for that position in the password. And every time we need to increment the password position, that password position for the intruder payload, for the attack. So this password 0, then this password 1. Etc., etc. Okay, finally, after 8 characters, when we do the attack, none of the letters come back as larger responses. So we infer that is the whole password we have. Okay, so the last thing we're going to do is we're going to write up a Python script to automate this entire process, because otherwise it's really painful. Otherwise it's super painful. Okay, let's, well, I get to test out my Python script writing abilities now. Great. Okay, so what would that script look like? Parasite, hello, nice to see you here. Okay, so we'll call this our Python editing window. What are we creating? We're doing a brute forcing script for this lab from Portswigger Academy. We're currently learning about NoSQL Injection, which is a type of identifying field names. Oh, okay. But yeah, NoSQL Injection is a type of database injection that is popular on Node.js apps. Well, it's a type of system that's popular on Node.js apps. Nice, maybe I can help. Oh, I mean, we've just finished one of the labs. What we're trying to do is we're trying to come up with a Python script that automates the process. So we're doing a brute force attack. And it might take me more than like 30 minutes to do this, but we'll see. Nano We'll call this brute Mongo. So we'll be writing the script in one window and we'll be executing in another window. What did you do with your overlays? Oh. The overlays are... Wait, did I have multiple overlays? Oh, I do. Yeah, that looks a bit messy. Sorry, I had too many overlays on at the same time. Okay, so I guess the first thing we want to do is we just want to figure out if we can connect to the page. So let's activate the lab again. Oh, what was the name of the library I want to use? So import requests. And then we need to figure out how to successfully authenticate, or like a session import request. Yeah. So we've got our lab. Where is our lab? Oh, you know what? You know what might be... Go would be even better. Would it be even better? Alright, let's put this in Burp Suite. I think what we can do is we can save the request file to... We can save the request to a file when we get to the... Well, the request to the user lookup endpoint. And then we can save it to a file and then we can feed it into Python. That's probably going to be a lot faster. Okay, we go to my account, we do Wiener Peter here. Okay, we reload the page. Then we save this out. Golang? I don't know how to code in Golang, unfortunately. Proxy, HTTP history, go down to the bottom and find the user lookup. Send this to the repeater. Okay, and just to make it a little bit easier, we'll just set our user to administrator. It's pretty easy. There's a tour to learn it. What does it feel like? Does Golang feel like... Okay, so we'll copy to a file. So request .txt. File already exists. Wait, I think we need to make sure we're saving in the right directory. Temp. And we'll save it in this directory. Whoops. Okay, it feels like C with superpowers and quirks. I thought Python was the best at automating things. Why Golang? I mean, I don't know. Why Golang in this case? Okay, so we've got temp HF. So in here is all of our information that we need to look up So I guess what we need to do is, the first thing we need to do is we need to parse this information and pass it off to, I wonder if Python can parse a request file from Burp Suite and make that request. There's CSRF and the login form, first issue to deal with. Oh, this is gonna be so fun. Okay, so I mean, I don't think we need to worry about that because we're just going to be using this. And if we're using this, we can use the same cookie session. Or is there CSRF? Where is it passed off? Okay, so let's just suppose we want to do this with curl, right? So if we're doing it with curl, then we need to pass in like a session cookie. Curl. Actually, can we curl using the request file? Oh, but you know what they do have though? You can do this. Copy as curl command. So any one of these requests, we can copy as a curl command, and then it doesn't really solve my problem here, but you know, it's nice to know. Let me paste it in here. Oh, this is really gnarly looking. And this comes back as HTTP 200 OK, but it doesn't give us the content. Wait. Do we need to add something here? It's already so freaking long. But anyways, to answer the question, yes, it can. Oh, I think you're talking about whether Python can. No, curl can. Curl can. So here we need to import the request file. So let's say like with open. What was it again? Parsing files. I did a lot of this in the. I did a lot of this before when I was doing Advent of Code. So all of these challenges required us to take in file input. So file path something something with open something as file. We take in the raw input, and then we need to parse it. So in this case, the file path is request.txt, raw input, print out the raw input. Okay. That's a lot of stuff to parse through. Okay, so what do we need to get from the raw input file? So from the raw input file, we need a number of different things. So the URL, the cookie, the parameter, the URL parameters, I don't think we need the refer or anything else like this. So we just need the cookie, the host, the endpoint. So the host, the endpoint, the cookie, the URL parameters. And I'm just gonna refresh this page every once in a while just to make sure that the lab doesn't go down. Okay, so let's identify these. So the first thing we want to get is the endpoint. Oh, but the endpoint is also included with this stuff. So get list equals raw input raw input 0, and then we need to further look into that. Well, this is not a list. We should also split this. And then print out the raw input in the get list. List object is not callable. Oh, wait, what was that? Oh, no. It should be this. Okay, so their get list is get and then user lookup, blah, blah, blah. And we need to split this one up as well. Okay, so get list and then endpoint equals get list element 1 dot split on get list dot split the first thing. Can we actually get that? Print endpoint. User lookup. Okay, so that it works. It works. Okay, so we have our endpoint. The next thing we need to get is the parameter. Or the URL parameter, or URL para, which is the same thing, but instead of 0, it's 1. Okay, user equals administrator. So this is our URL parameter. Good. What else do we need to get? So our endpoint or URL parameters are host. So host equals, it's up here somewhere, the second object in the raw input. But we also need to strip out that new line. So host raw equals raw input 1 dot split on and we just want the second element. Like this. Host raw. Okay, good. Good. This stuff is all coming out. The new line actually comes out too. Huh. Why? Oh, the new line rendered. We don't want that. Okay. So hostname equals host raw split. So we want to stop 2 characters before. So 2 characters before would be -1. Next, wait, -1 is the last character. We want to do -2. And we want to print that out. Something went wrong here. So not -2, -0 maybe? And what if we don't do anything? So I guess we didn't need to snip off the new line, because it doesn't seem to be there. Okay, I mean, if it works, it works. So the first thing we want to do is we just want to make a request. So just a simple request to make sure that this thing responds properly. Okay, so let's look it up. Python requests module with URL parameter. Okay, so we need the URL. We need our query parameters. So the query, you have to define your URL parameters as a dictionary. Oh. Okay, and then make the GET request. So request.get. Okay. So that's okay. So the full URL equals f-string HTTP. This is an HTTPS though, right? Oh, this is just regular HTTP. Okay. So HTTP host name host / endpoint. Then we need to send our URL parameters. So the URL parameters are user equals administrator. But I mean we can just set it here because we're going to put in some we're going to be putting in our own like malicious ones later. So it'll be URL without this. Okay, so dictionary user administrator. And I just need to keep on refreshing to make sure that the page doesn't die. Okay, so request first test request. Test request equals requests.get. And what was the syntax? URL params equals query parameters, like this. And then print response.url. Print the final URL to see if how the parameters were appended. Okay, so there was another thing to actually get the response, right? So it's going to be to, like, what was it, full URL? And params equals URL params. Okay, and then we print out the response. Print test rec. Oh, we also need cookies. I forgot about that. So we got the endpoint, we've got the host, and we need the cookies. I'm pretty sure the cookies are saved as a dictionary, right? So we'll just do cookie name and cookie value, and then we'll do cookie dictionary. So cookie name is this is 1, 2. So raw input. Whoops. Raw input something something split. So the cookie name is raw input 0, 1, 2. And we'll split it by it looks like we need to split it by space. So split by space first. And then we split it again. Split it by space and then element. Element 1, which is the second thing, and we can split it again. And this time we're splitting it by the colon. No, splitting it by the equal sign. And then that's element 0. So let's see if we can print this out. We're printing out the cookie value. Oh, cookie name. Session. Okay, good, good. The next thing we need to do is get the value. So it's the same thing as this. Except we're getting the other value. Then we'll print out cookie value to make sure it is what we want. Yes, this is the cookie value. Okay, everybody, I'm not anywhere close to finishing the script, but I'll have to hack away at it after the stream is over, and I will report back with my findings, I guess, next time. Okay, so should probably find somebody who's awesome on InfoSec streams that we could raid into. Hold on. So this is a list of people who do live streaming on Twitch and on YouTube. Hey, Sergeant, nice to see you here. I'm the only person who's streaming right now. Let me check Twitch to see who else is on. So maybe some people that are not on the list. Science Streams is on. Awesome. Let's raid into them. Okay, so we'll start the raid, and then we'll talk a little bit, and then we'll end it. Raid Science Streams. Okay, so when you arrive on the Science Stream channel, if you could give this raid message, I would really appreciate it. OS Frog, hip hop, hack OS Frog. Just like this. Okay, we're gonna be back on... Well, I think we talked about it earlier. So we made up our schedule a little bit earlier today. So we're going to be streaming on Sunday, Tuesday, Wednesday, and Friday next week. And yeah, so the regular streams are going to be on Wednesday and Friday, but on Sunday and Tuesday, we're going to be doing some coding, Leak Code Quest. We might be doing this Python code, this Python script on that day instead. And on Tuesday, we're going to be doing our C coding and learning. Sergeant says, I have a question. Yeah, sure. Do you have a question? Let us know. If you want to know about how to get into cybersecurity, I've got a link over here that you can look at. But otherwise, we need to get going pretty soon. But yeah, please come back on Sunday, and we're going to be doing our casual coding stream. It's going to be a lot of fun. But until then, have a great weekend, and we'll see you next time, okay?
Oh no, I haven't played it, Mr. Goldman. I'm sorry.